make sure I don't have any passwords on my desktop.
Oh yeah.
It's such a bad thing. Like I should, because I stream, run a separate streaming computer, and I just don't.
Yeah.
And that's going to bite me someday. Like, I'm going to get sued for $50 million for accidentally divulging Sony secrets or something.
Oh yeah, yeah.
Yeah.
Just like the name of the
Yeah, who knows?
project, right? Like there's a folder on your desk or something.
Yeah, who knows?
I guess stop putting things on your desk, but
Well, I don't. So all of our actual console stuff happens in the office. So that the thing that I specifically just said is not an actual danger, but like who knows, right? Who knows what I just had on my desktop last night that I forgot about?
oh, is my voice okay?
People are saying you are echoing, which I guess.
That would mean
that probably means I'm just picking it up. It either means I'm picking it up.
But I don't hear an echo.
Yeah, it might just be going into my mic, right? Because sometimes you can depend on echo cancellation and other times not.
But if it's going into your mic, I would hear it, wouldn't I?
Yeah, probably.
So I think that, I don't know what would cause it.
Yeah, someone says it sounds like audio source twice, but we do not have two audio sources as far as I know. So like if I turn off desktop audio now, say something.
Testing, testing.
Did people hear Sean say testing, testing? Probably not, except maybe faintly through the mic. Wait, still echoing?
Still echo? What?
What are you even talking about? See, this is why I can't trust Twitch chat. Like, I literally, the things they say don't make any sense.
Yeah, it's very odd. I just sound like I have reverb when I check the Twitch stream.
I think maybe you just sound to them like you sound to me, but
yeah, I imagine
they just complain a lot.
Yeah, well, I mean, the problem is echo and reverb are two different things, and from our technical perspective,
yeah. Let me. Okay.
They use them interchangeably.
Here, I'm gonna.
This is how music technology is. I listen to the Twitch stream, and you sounded fine, but on this over the Discord, you are like distorting over loud, and it's totally fine. Don't try to fix it.
Well, let me because I'm gonna be.
Welcome to fucking technology.
Yeah, I'm gonna go listen to.
It's probably getting my wrong mic. I'll check.
Yeah.
It's probably using the wrong mic for me. It's probably using my webcam mic instead of my actual mic. No, it's using my correct thing. I sound totally normal in my local test.
So now, of course, in order for me to check this on my phone to see if it sounds okay, I have to find the special iPhone audio jack because I can't just plug in any headphones to my phone. Because
so the reverb is not coming from my end. I don't know how it's happening, but
let me just check because I might have had your levels turned up from PUBG a long time ago or something. I don't remember how to do that. Like can I write user volume is 100%?
I wonder if I'm hearing a different microphone than they're hearing, right? You have your OBS hearing some microphone, and you have some microphones set for Discord, and they're different. So they're hearing me through your thing, and I'm hearing this distorted voice on Discord.
People say it sounds good right now. I did not change anything. I did not turn down anything. Nobody changed anything. You guys are all hallucinating. Nobody did a single thing.
All right, I'm not trying to listen to myself again. Let's see what's going on. Testing. I'm super quiet on the stream now.
Well, so that might just be that you are coming through the mic. All right, so here's what I'm going to do is I'm going to turn back on the desktop and I'm going to listen to you through headphones, because relying on noise filtering is insanity when people can't even do anything right in software, and that's an actual hard thing.
On the Discord echo, but only when I talked over you, like so that
Yeah.
you were talking and I could hear the echo.
All right, so I'm on headphones and you are on desktop audio.
All right.
Okay.
Great.
Now everybody is saying it's good.
Everybody's happy. I still hear you distorted, and that's fine. Doesn't
Okay.
Don't touch anything.
Let me Twitter announce this, and then we will, I don't know, say things in a few minutes. We'll give people a few minutes to show up. Special guest Sean Barrett to talk about, I don't know, what are we talking about? Making software fast or preventing it from being slow, specifically with regarding compilers, but maybe other stuff too. Who knows where the conversation will go? Okay. Cool.
Oh, I should have done this research in advance. Dang it.
All right, I'm going to make some tea, and we will give people a few minutes. All right, tea time. Back in a second.
Well, hello there. I'm not going to do a Casey ramble, so let me just wait.
Okay.
All right.
So let me put my camera up so that people
Yes.
can maybe see me as well. I don't know how good of an idea that is. If we're showing code on your side, maybe I'll remember to remove that. Okay, chat, your job is also to make sure that my tea doesn't oversteep. So in 3 or 4 minutes, you have to tell me about that. And well, it seems like we have a lot of people here. We have about 600 people, which is plenty, I think. So I guess, how do I want to put a little mark on the stream for later, and they've taken all the useful things out of the UI now, so I can't
I
do
just stopped the stream and started again.
that. I'll just find it later. Anyway. So thank you everybody for showing up. You know, we've done a couple of discussion type chats with Casey so far, and those ended up being nice. So I said, hey, why don't we give Casey a break and try doing them with other people too? So also on the line is Sean Barrett, who I've known for a really long time, off and on. I think I met him in probably 1997 or something, 1998. Yeah. You know, he's one of these people who's been in games for a long time and has had a lot of experience working on them in different contexts. And he's working on a C compiler right now, among other things. I guess we'll talk about that. And how often do you stream programming, Sean?
I have not. I streamed programming yesterday, but I have gone. I probably only streamed like once in the last 2 years or so.
Oh, okay.
So I was doing very regular streaming of this project called OBBG.
Yeah.
Just trying to do a handmade hero-y kind of watch somebody program thing, and
Yeah.
and I just did it enough. I was done.
And a bunch of those are on YouTube, right? Or are they
Yeah,
all
the
on
entire
YouTube?
series. The entire series is on YouTube. There's a playlist. I can link it.
Yeah. So I guess we won't point people at your stream right now unless you decide you want to go back into that business.
Well, I did stream yesterday, so I probably during the work from home period, I'm going to try to stream
Yeah.
a couple times a week, probably.
Yeah. His stream is twitch.tv/nothings2 if you care, because I don't know, somebody had nothings with no two, right? That's how that always works.
Yeah,
And
exactly.
it's probably some abandoned user who never will use the name. All right, so we were going to talk about something involving gameplay things today, which I think would have been a better subject break than talking about more compiler stuff. But I still need a little bit more time on the gameplay thing. The thing that I'm working on is not quite done. It will be done soon, maybe a few days, but it's not quite done. So we decided to talk about compiler things today. So Sean, why don't you say a little bit, because you're writing a C compiler, and I didn't really know that. So maybe mention a little bit what you're doing and why.
Yeah. So you mentioned on one of your streams that you've written a bunch of compilers over the year, but this is your first production compiler in that sense.
Yeah.
And I have basically the same experience. I've probably written a dozen compilers, almost always for an interpreted environment. And none of them were production quality, but some of them were meant to ship to hobbyist users, so they weren't like total jokes. And now, starting in around Thanksgiving, I started writing a C compiler. This is for Red. It's basically an experiment. Jeff and I had talked about this on and off over the years, and he just felt like it was probably too much work. And then he talked to you, I guess, for a while about your experience with your compiler, and decided to go ahead and pull the trigger and try it out.
So the
So
goal
our
being, well, go ahead. Yeah.
yeah, so the goal is pretty different from yours. I mean, the goal
Yeah.
is ideally, it's an experiment. So, but the goal is maybe we can come up with a compiler that Jeff can use and that Rad can use. Our goal is not to ship it to end customers. Don't want the support load of being a real. We want a system that we know what's going on under the hood. Um, for example, because sometimes you optimize something by looking at the compiler output and not going to assembly. You don't want to quite go that far.
Yeah.
So you look at the compiler output and tweak it. And then, the compiler changes or it's a different compiler on a console and stuff like that. So by having a single thing that we control, like that's an example of a possible benefit.
So, there's so many things to ask about. I mean, I also don't know how much we want to be in the business of saying what is going on at Rad or anything, but like, so
No,
is
I'm being very careful about that. You can ask whatever you want, and I
yeah.
will filter that.
Well, so when you talk about wanting to make the compiler fast, right? Is that because speed is a primary deliverable because the Microsoft C compiler is too slow, or is it because, well, of course, speed is always desirable.
It's it's definitely more of the
But
latter. A project that I did a while back for
yeah.
Rad was we were using HTML compiled help, the CHM, for our help files,
Hmm.
which is a Microsoft system, and basically we used our own internal generators and just used their final backend compiler, which compresses the help file and merges it all together,
Hmm.
and uh, it has some problems, some issues. And so we were like, let's use modern HTML and pack it all into one big HTML file, not compressed. And you have it use HTML to be able to switch between pages and stuff instead of doing it with this weird chum mechanism. And so I spent a
Yeah.
lot of time on that. But the upshot of that was I didn't spend any time optimizing it, but what we got at the end ran way faster than the chum compiler. Of course, the chum compiler had to do compression, so it like had to do some work. But the point was like my natural inclination of how I create things tends to be fast. And Jeff kind of looked at that thing and was like, he just expects, oh, what he'll get out of it is a fast compiler. But it wasn't his 100% primary focus.
Yeah.
And because, yeah, I don't want to talk too much about it, but, RAD libraries we compile them on a lot of platforms, but they're often not huge game engines, right? They're relatively small. So compile performance doesn't tend to be as much of an issue as other things. But my project was definitely, I would used to have a 2-minute build if I built all
Yeah.
platforms.
Yeah.
So he has certain goals for it, and I added on my extra goal is I want to make the fastest compiler I can think of.
Right.
But
Right.
it's not his requirement. That's just I have the privilege of being able to go ahead and put that extra constraint on it, and he doesn't mind me putting that constraint.
But so the main functional requirements are maybe something about like predictability of what the compiler is going to do or something that
So
enable you to work with it.
the reality is that we're going to play with it and see what things we have a bunch of things we'd like to get out of it.
Yeah.
And I don't want to go into a lot of detail about it just because it's not so much secret as it's like we don't know what's going to work. So we have some things we want to try. We'll put in a couple extensions probably. Let's see. I'm trying to like think of sort of vague things that I can say. One thing that Jeff has always wanted to do is because we make libraries, he'd really like to strip the library public symbols down to just the things that need to be public.
Mm-hmm.
And a lot of library systems don't really have a mechanism for that. Like DLLs do, but libraries don't normally. And so we've talked about ways to do that before we had the compiler. Like, can we, how could we mark this up? How can we strip those symbols or whatever? And if we're just doing our own compiler, like one option is, compile it all to one big OBJ, like you do. And then in that OBJ, we can internally link anything that's not supposed to be a public symbol. So like, that's just an example of a thing we can do once we have more control over the pipeline.
Well, I mean, honestly, so that latter thing you mentioned about internal symbol resolution. Like, I don't understand why that's not standard. I mean, I sort of do, because we grew up with this C compilation model where everything's a tiny.o, and then it's somebody else's job to deal with that, right? But it's really inefficient for most programs, you know? And I mean, you could say like, well, I guess it's flexible because you could redefine the names or whatever, or
Yeah,
you know,
well, and
override them.
people
But
do-
nobody ever wants to do that, hardly, except in
People
very rare
actually did
cases.
do that. That was the standard way to replace malloc, is to use the library
Well,
mechanism.
whose fault is that, though, right? You know.
Yeah, I agree.
Yeah. So, but I mean, you know, even if there's specific cases like that, you should just be able to tell the compiler, like, look, you know, these symbols are going to be referred to. You know, I mean, currently, everybody has extensions for these things now. Some of them are weird, right? But like, look, this symbol is exported by this program for whatever weird reason. So there's, you know, I don't know if you've even seen this, because this is maybe more of a game thing, but like, there are special magic symbols that like graphics drivers look for in your executable now to know what to do. So like, if you're running on a so-called Optimus laptop, right, that has the low power GPU and the high power GPU,
Right.
both AMD and NVIDIA have different symbols for if they see that symbol, then they'll run by default on the high power GPU, even if you're not in the whitelist or whatever, right?
And that's a symbol they publicly tell. It's not they're looking for, oh, you happen to use this function. They say put this declaration in your code.
Yes.
Enough to do it. Yeah.
Yes, and it's you know, I think it's just a data symbol, or it's a Boolean maybe. I don't remember, but like, you know, that's just an example of, you want to very straightforwardly say, I would like this symbol exported from this program, which is, I mean, that's a kind of a thing that if the goal of your language is to interoperate with the world, that's just the kind of thing that you want to say. And in the C world, that's sort of relegated to weird linker scripts or whatever that are going to be different on every operating system. There's like no way to really express it directly. And that causes a lot of problems, really.
But like you're saying, it's a historical artifact, and it's really not surprising nobody's fixed it, because we got this whole new language, C++, with reams and reams of stuff, and to achieve its success in the marketplace, they had to not touch the linker. Like, they had to do all the name mingling and stuff and make sure the existing linker would just work. So if C++ couldn't touch the linker, it's not surprising nobody's coming along and demanding this.
Well, and so the thing about the linker too, I complain about linkers all the time, so I won't do it too much, but like, most of the actual work that the linker was supposed to do, we don't actually do anymore, right?
Yeah, we do it in the loader, right?
Yeah, we do it because so again, you know, there's this thing now, you know, because people want to hack your computer and stuff, you want to at load time, when you load a program, you want to change the addresses of all the code around, right?
Right.
So address space layout, reorganize. What's the R stand for?
Address space
Randomization. Yeah.
Layout,
for example.
ASLR.
Yeah. So that's one example of like a way that we mess with things today. But like that, the linker's or not entire job, but a large part of its job used to be to assign addresses to the things in your program, so that when you loaded the program, you wouldn't have to do this work, right? This was back when computers were a lot slower, and the calculus of what made sense to do at startup time versus compile time was different, right? And now we just say like, look, for security, we're going to do this thing that's probably a little slower, but it's worth it. And so that was kind of the linker's main job, right? Then with C specifically, another one of its main job is to deal with all the inefficiencies generated by the compilation model, right? So when you compile a C program, every time you include a header file, like debug info for every struct in that header file gets added to the .o file, right? And then the linker's job is to notice that those are all the same, and then to only put them once, right? And it's and that makes mistakes sometimes, apparently. I've had weird stuff happen. But it's also just slow, right? And so the linker mostly does things
but it's also not, like, it's slow in a way it shouldn't be slow. Like, right? Like, it's not oh gosh, any program that has to do that much work is going to take that long.
Yeah.
Right?
No,
Yeah.
but and it's so weird. Like I don't live in that world in part on purpose. Like just like I limit
Yep.
my exposure to World Wide Web things because I don't want to catch web disease and stuff. Just some of that stuff. It's not exactly the same. Like I think compiler and linker people certainly know way more about how computers work than, for example, web people. So that's not the problem. Let me go to a blank buffer so I don't distract people here. But they're not really allergic to system complexity in the way that everybody needs to be today,
Right.
I think. And that's a weird thing. Like everybody's just fine with building on top of all these things that have problems. So something like a linker creates a lot of problems. For example, it just puts all the names together, and is it the first person to use a name gets it? I think so, right? And so you can have silent failures where, multiple objects wanted to use a name, and one of them took the name and the other one didn't, right? And that's just because it was simpler times when these formats were invented, right? You can't, so you can't express this in C at all, for example, but like you can't say, I want to link to this symbol only from this particular library. Like I want to, like, it's good policy when you're writing a structured program with strong type checking and stuff to make sure that you're calling the thing that you want to call. And so like if you have an overloaded function, for example, you have type checking on the arguments, and that's how you make sure you're calling the right one, among other reasons, right? Or other mechanisms. But somehow that disappears in the linker. It's just like a name with some stuff. And you kind of rely on mangling to do the type checking, which is stupid and horrible. But then if you're not mangling, then you have this just aliasing problem, essentially. And like that's a really bad thing. Like if we're talking about making programs more robust and less error prone and removing all the stupid mistakes that people make, because there's enough non-stupid mistakes, right? Like programming is already just hard. So if we talk about removing all the stupid stuff, these are some very bad flaws to have at the core of the system, I think. It doesn't, like if you were to write the equivalent thing of a linker today without even referring to previous systems, but just like, look, I want to compile some stuff in different languages and I want them to interface in a robust way in the year 2020, it wouldn't look that much like a current linker, I don't think. And I don't know, you certainly wouldn't relegate some of these things that seem pretty important, like making sure you got the right symbol from the right library, to weird OS-dependent linker scripts in cases where that's even possible, which like I'm not even sure on which systems that's possible. I just know different linkers have different hacks. Oh, but the other thing I was going to say, getting back to the topic of speed, because that's sort of what we advertised we would talk about, yep. Although I'm totally fine not going anywhere. There was this whole thing where like even people in the compiler world were realizing that linkers were slow, right? And so then they did this like gold linker, right? Which I guess was a Google project or something. And it was like 2 times as fast as LD. And that was supposed to be amazing. And I'm just like, what are you guys talking about, right? Your thing is doing almost no useful work and you're 2 times as fast. It just doesn't, on the one hand, I understand why somebody thinks 2 times as fast is good, because if you had a program that was doing 100% useful work, speeding that up by 2x, that's pretty good, right? Like if your program is already working hard, a 10% optimization is a really good win. But like when your program is mostly a waste of time, 2x is just getting started, right? That's like what you need to get before coffee in the morning in order to get it down to where it needs to go.
Yeah, well, back when Go came out, people were just talking all over the place about how fast the Go compiler was. And even back then, like I looked at that and I was like, this compiler is like 10 times slower than a fast compiler could be. It felt like. And it's just that same thing, right? Like people's expectations are just weird. Like,
well, so we have a superpower our superpower is that we're old, right?
Yeah,
So we've
exactly.
seen this stuff happen over time. So I will say that I don't know if this is true anymore, but for years, Sean used Visual C++6. Is that still correct?
I do still use it. Yeah.
Because the C compiler is way, way faster than any current or any
It's not
the
actually
current
why
Microsoft C compiler.
It's not actually why I use it. I use it for user interface reasons, but in practice, in fact, it doesn't do multi-core builds. It only builds on a single core.
Oh yeah, that's true. So that's a disadvantage.
But because I'm only building like 20,000 line programs, it's still basically instantaneous.
Okay. But like, there's this thing that happened. So, because we're old, like we kind of know how fast compilers used to be relative to the machines they were running on,
Yeah,
right?
exactly.
And then we know today's machines are way, way, way faster. So why are the compilers like, they're probably a little bit faster in wall clock time than they used to be. It's hard to say because projects are different degrees of mess. I definitely was on some projects in the early 2000s where the compile time was 45 minutes, right?
Yeah. I built the Unreal Engine once in the
Yeah.
2000s
Yeah.
as a contractor.
That's what I was
And
thinking
yeah,
of.
and it's,
Unreal Engine. But then also, I mean, there were some template heavy projects. I won't name names, but there was something like one programmer managed to make something that took 45 minutes to compile. That was, a mostly 2D game. So like, there definitely were slow things back then, but it wasn't like super normal. So all my projects, would compile in under a minute. If they were not huge and didn't use a lot of external stuff, I remember numbers like 7 seconds or 12 seconds on a laptop. That was kind of typical. I don't remember how many lines of code that was. It probably wasn't as many as I deal in today, but it was a significant program. It was like a game that did stuff, And today, I don't know what it takes to have a 7-second C++ compiled today, but I don't feel like I've seen one in a long time. In part, that might just be because I gave up, like trying to make it compile fast because you have to work so hard. Oh, and in part, here's where we can start saying some things about speed. There is a very clear trade-off in C++ if you really care about performance between compile speed and runtime speed. And that's a problem. So what I used to do in all my games and stuff, there's this very simple thing you could do. Let me go into, I don't know. I'm just going to go into a random, whoops, that's not. I go into a random header file in the compiler, for example, where the syntax tree is defined. And I forward declare all my structs up here at the beginning, right? And as long as you do this in C or C++, you can use pointers to these structs, but they don't have to be included, right? Because the compiler doesn't need to know anything about, it just knows that some type called this. So other structs, right, don't implicitly coerce to that. So it's a type check error if you try to pass the wrong type. And we know how big it is because it's a pointer, right? And then if you only if you want to dereference the pointer, do you do that? And that goes a long way toward making your compiles fast, and you do it all the time. However, once I started putting this compiler together, and I was really measuring like very closely, if I do this, how much time does it take? If I do that, how much time does it take? It could cost easily 3 to 5% of compile time to have something be a pointer versus not be a pointer. Like even if I wasn't doing really inefficient heap allocation, like I'm just doing bump allocation and whatever, maybe it didn't always end up in the same cache line. I don't know, probably it did. But just going through that pointer sometimes was a problem. So as this compiler went on through the first few years, it's scary to say first few years, but I've been working on it for a long time. I don't remember any, probably in here, there's a lot of stuff. I just slowly put more and more things on the host struct rather than being a pointer because I could measure the difference. And, you only have to pay 3% enough times before it's a pretty big percentage, right? And so I just include tons of stuff. It's just a mess at this point. Like I used to try to be very careful about arranging include files, but one thing about having an escape pod to my own programming language is I'm just tired of C++'s bullshit, and I just won't put up with it anymore. So I'm actually not that careful, but here's this general.h thing that includes a bunch of things that I use everywhere. And then, this also, most things probably include this interp.h. So just a bunch of things that we include. Many of those because I just don't want to do this pointer trick that lets you compile faster. So I'm compiling slower, but in return, I'm getting faster runtime. And that's not good. It's good if you're talking about optimizing functions or something, right? But here you're just talking about bureaucratic administration work. It's not good to have a trade-off around that, I don't think.
Yep.
Have you ever done that, Sean? Have you measured that difference or seen what I'm talking about?
I don't think I've done that specific. It's so interconnected to structure of array kinds of stuff that I don't know. Maybe I've done something like that. I don't recall offhand.
Yeah. So one thing I will say here is, so Sean and I historically have very different programming styles. I don't even know what Sean's look like these days. But I would describe my style as I'm just really worried about getting something done more than making it fast initially. So I don't try that hard to make it fast initially, but I also try very hard to not drop roadblocks in my place that are going to keep it from getting fast or make it slow, right? So, or if I do make it slow just to get something done, it's on my to-do list to remove that tomorrow, right? So that has some upsides, it has some downsides, right? So I'm not saying that my style is better than anyone else's, it's just the way that I do it. And so Sean, I think that you have a much more of thinking from day one about look, I don't want to have this ever be slow.
Yeah. So go ahead.
I think one place that I want to get to during this conversation is places where I've seen my method maybe be a drawback. It's hard to really know because you can't A/B test in parallel universes about doing it two different ways and just see what happened. And even if you could, you would need 100 trials in each one, right? But I remember from back in the day, you would think very much about packing things and, putting, if you knew an integer only needed to be so large, you would pack it with other integers from day one. And I don't do that kind of thing.
Absolutely. I still do that.
So do you want to talk about that a little bit?
Yeah. So let me talk about my compiler a little bit, because I want to clarify what the state of the compiler is. So I'm writing kind of a traditional compiler that goes through multiple phases. There's a preprocessor, a lexer, a parser, a type checker, intermediate representation generator, optimization, and final code generation.
Yeah.
And I'm implementing this sequentially, right? Rather than implement a tiny portion of it all the way through, be able to, do a single operation all the way through or whatever. So I'm actually only to the type checking stage. So I don't have any experience with the later stages yet.
Sure.
And I don't have any performance data about the parsing and type checking stages yet, which means all of the pre-optimization work I've done there is super speculative. I don't actually know if it's valuable.
So you don't measure it at all, even casually, or what?
No, not yet.
Okay.
And I have looked at the performance of the preprocessor and lexer, but I didn't ever use anything like vtune to actually look at what's going on under the hood. I just made guesses and made a couple tweaks and saw how the performance changed.
Dude, last time I tried to use vtune, I just couldn't use it effectively.
That's why I haven't. Fabian absolutely swears that you've got to do it these days. That you've got to look at the whatever you call them, the internal monitoring variables, whatever that word for that is, so that
the performance counters or
performance counters, yeah. So that what's actually going wrong.
So I agree with that, but the problem that I have with vtune is, right, it's a sampling-based profiler, and they only let you sample 0.1 milliseconds every 0.1 milliseconds, which if you're not missing the cache all the time, like that's a long time between samples. And what I found last time I tried to use vtune on this compiler was, in compiling my 100,000 line program, this game, right, that we show sometimes on the stream, I would go to some of the functions that I knew were bottlenecks, right? That like telemetry, for example, was telling me were slow, and that made sense that they were slow, right? And I would look at them in vtune, and there would be like a smattering of samples in there, even with everything turned up to max. And it's just like, well, I guess, a 0.6 second compile run on this 100,000 line program doesn't execute that path enough times for the sampler to hit it, right? But then I need to like rewrite my compiler to loop 1,000 times and recompile the same thing. Like, and it's just not, it's not made that way right now. So like right now we would run out of memory if we did that because we don't free anything. And I can do that engineering work, but it's like a lot of engineering work.
And vtune didn't have a way to run it 1,000 times.
Not that I saw, not that was useful. And this might just be me not really knowing how to use it, but like, it's clearly trying to be a tool for a general user. Like they have all sorts of really stupid clippy like user interface stuff in there. So like, I don't know, maybe I'll go back to it and try sometime, but I put a good 4 or 5 hours into trying to use it and I just couldn't get anything out of it.
Anyway,
but again, Fabian says it's great. So I don't know.
Yeah. I mean, I bounced off vtune many times because of the user interface, because it was always, like I would try it every N years, and the user interface was written by an intern or something. It felt like I'm sorry to insult somebody at Intel, but I could never get in touch with the user interface back then. Fabian says that's better as well. I don't know. I literally haven't tried it since. But anyway, so I was just talking about the profiling or whatever I did. So mostly what I've done is try to write it in a way that I think is fast, measured it and found it was fast, and haven't really done. I like tweaked a couple things.
Yeah.
So I don't have good data on this. All I can talk is, for the most part, all I can really talk about is speculative. I have useful data from the preprocessor and the Lexer, but for you that stuff isn't as interesting. So we can talk about it. We'll figure it out. But so I did want to talk about that size stuff because you'd mentioned that. So my rule of thumb that I use right now when I optimize code, I have a couple rules of thumb about where performance goes, right? So one is mispredicted branches, and two is memory access, right? Mm-hmm. So that's like the starting point. So the rule of thumb on mispredicted branches is, avoid switch statements that you expect are unpredictable, avoid ifs that are random. And however it is that you can think about that, data-oriented design is like one way of thinking about that is like, instead of iterating over a heterogeneous collection of things, like if you have two different kinds of things intermixed in an array, like separate them into two separate arrays and iterate over them and don't pay that if inside the array. Like that's an example of a strategy. And then for the memory access stuff, there's a few things you can do. You can try to keep things small, which means packing your structures. Allocating sequentially, mainly that's because you have a hardware prefetcher. So allocating sequentially keeps things in the same cache lines, but also lets the hardware prefetcher fetch things if you actually go back in the same order, which I know you talked about for your allocation stuff. So, and then structure of array stuff occasionally, like saying, okay, like I might even have a structure that is, splitting stuff up. I know this isn't accessed at the same time that this other thing is, so I'll separate it. I got some actual performance data in my Lexer I had a structure that had two arrays and I split it to a third array, and that actually saved me some time. And then sometimes it's the opposite. It's like, I know this is accessed randomly, and this structure is 50 bytes. Let me pad it out to 64 and align it. But I don't have any actual data from doing that. But the idea there being that then that structure, once you hit that cache line, you'll always, all of the data will always be live in it.
And so that's strictly a single thread thing? Like you're not worried about false sharing as well?
Yeah, so that's definitely a thing to worry about. In my compiler, I'm doing a single threaded thing where I'm doing a classic. So we might want to go down the Jai path of trying to link it all together. Trying to build it all together. But one of the big reasons in my mental model of your compiler, the big reason that you have to do that is because of the metaprogramming stuff. You need all of the metaprograms loaded before you can start compiling anything else, so that they can run and
yeah, that's not really the reason. Really, the reason is that there's just not any lexical ordering to programs. So even if you did zero metaprogramming, we don't have header files, nor do we have, I guess like some programming languages, when you say import whatever, it like requires that thing to be fully done or whatever, and we don't do anything like that.
Yeah.
So
so our model is the classic model, like incremental compilation. I want a full rebuild to be fast, but probably like it's one of those things where Jeff was like, oh, let's just not even do incremental compilation. I'm like, well, maybe it'll be fast enough that that's true, but I'm planning on the incremental compilation. And I thought about having one process be able to compile multiple files in parallel, but I decided it's better to just stick to a single thread and use multiple processes to compile multiple files, just because that lets the make system schedule all, because it's still going to be building some C++ files. It's still got all that stuff to do. So if I'm internally trying to use multiple threads, it's going to be a mess.
Yeah, I mean, I just want to get rid of all that stuff. But if your goal is to interoperate with that stuff, then it's like,
exactly,
hey, just
right. Like, so it's
right?
just different goals. So packing things small, allocating sequentially, and then the mispredicted branches. That's my entire optimization model, because it is single threaded.
So I'm not sure. I have things that I'm thinking about, but they might be too big of a leap from where we are. So I will say, like I said, my approach tends to be lazy, where I'll try to do something where I'm not that worried about performance yet, and I clean it up later, basically. But I mean, okay. So I started saying this as though it was a very general thing, but I guess this applies to this specific compiler. So I'll make it more specific. When I started making this particular language design and this compiler implementation at the same time, I didn't really know what the language design was, right? I remember talking to you about it very early on, and like we were talking about like syntax options and stuff, and like I had no idea what even most of the language was going to be, right? And so under those circumstances, you kind of lean on what you know from other contexts and stuff, right? And so, like you mentioned, I've done a bunch of interpreter kind of things. I know how compilers go, and so I ended up making this thing where you lex and you parse stuff into a syntax tree, and you go do stuff with that syntax tree, right? As soon as you're conceptualizing things as a tree that way, it's hard to do SOA kind of stuff.
Absolutely. This is a big rant that I kind of have about all of the Mike Acton talks. Is every time I would look at those, I was working on this UI tool called Iggy that takes lets you author in Flash. So its input is Flash content, and Flash creates basically a scene graph, but it's a big tree, and it's a tree of very heterogeneous stuff. And a heterogeneous tree is just pretty much the worst for that style of programming.
Yeah.
And the compiler, guess what? Yeah, you have a syntax tree, and it's a heterogeneous, messy tree.
Yeah, and so the thing though is the more this implementation goes along, and the more I see, like the best kinds of engineering solutions are the kind that address multiple problems at once, right? Like, oh, we have these 7 problems, and if we redesign in this way, it'll at least have a positive bearing on 4 of those 7 problems. And so that's a thing that we can do combined with other things, right? And so let me talk about one of the problems I have that is not strictly a performance problem, but then I'll link it back to performance, right? This might be a little bit of a long explanation, but so let's go back to this syntax tree file. So this is where a bunch of the nodes from the syntax tree of this language are defined. And, we have sort of this ast expression. They all start with ast, and expression, that's a common term in programming language design, right? And expression is just like a very general thing. Like expression just sort of means it produces a value, probably, right? It doesn't even necessarily have to mean that. Like in a C style language, you could produce a void value if you want, and so on. So I have a bunch of these nodes. They're all sort of subclassed off expression. I do use very limited C++, so I do this sometimes, but like there's not multiple inheritance. There's not like virtual functions on these. There's not methods, like none of that stuff. There's no templates here. There's a little bit of templating in this program, but not very much. So when you say like defer and something, we make this node, and inside this block, we put whatever the statements are inside the defer. It's pretty straightforward, what I'm saying so far, if you have done programming languages before. This is very, very standard. Now, one thing that is not standard about this language is the following. So we parse things into a syntax tree, and then we give them, for example, to your meta program or whatever, or put them later in the compilation pipeline and just generate the output program from that. But as a program that is generating and modifying code, your program can like take the syntax tree for a function, mess around with it, and hand it back to the compiler, right? And so what that means is that, so first of all, the parser is not the only place that a syntax tree can come from. There are two sources, right? And I suppose this is true in other forms for some other compilers. So like, if you have a compiler that has pre-compiled headers, those are probably trees that are serialized in some way that's like not the regular syntax of the language and whatever. But so first of all, that introduces some weirdness because well, that starts conflicting with being fast, right? So first of all, if you knew that your syntax trees were only going to come from parsing, right? You might be tempted to do some simple things, right? Like if you knew that a thing could never return a value or something, but you saw that it was trying to return a value, like syntactically, you might like just start checking for that error up there because like, it's fresh, it's in cache right there. The thing is available. So like do that, right? I'm having trouble thinking of specific examples, but there were definitely a bunch of things like that where initially I would just put certain kinds of error checking into the parser or certain kinds of maybe even tree rewriting. I'll get back to that in a second. We don't allow tree rewriting anymore. Well, I'll just say it now because you don't, like the whole point of your meta program being able to look at the structure of your program is that you can do intelligent things with it. And if it gets totally desugared and messed around with in wacky ways, like is vogue in compilers, you may not be able to map that back to the original program, or it just may not be that enjoyable to look at, right? It may introduce a lot of extra cognitive load for programmers trying to understand what's going on. So we actually don't allow tree rewrites that are visible to the user. So we do rewrites like way later in type checking now. So anyway, like that already, it just starts having an impact on performance immediately because you're saying, well, there's more of a wall here, right? Like there's stuff the parser generates, which by the way, could be generated by something else. And then on the other side of this line is the stuff that you have in the type checker and later, right? And as soon as you say that, it's like, well, you probably shouldn't have to be trying to do all those things as soon as you create the node, because then you have to duplicate all that code and it's error prone and it's probably doing two slightly different versions of the same thing, and that's complicated. But the thing that's a bigger complication and that I may actually change, like in my imagination when I have a lot of free time, I would do this soon, but like that's not going to happen. So the problem is all these syntax tree nodes, I did these. My concern all the time is that everything you do to a program makes it slower unless you're explicitly trying to make it faster, right? Like if you add an if statement somewhere, your program just probably got epsilon slower, aside from like, random cache effects or whatever. So you kind of, if you want to make fast software, you have to at least be aware that that's happening all the time and a little bit paranoid about it, right? And so if I were wearing my academic compiler hat, and I would say, well, compilers want to be very clean and want to be very well factored. And so every phase of compilation would have a separate set of data structures where all that information is stored. And so when you come out of parsing, you would only have data relevant to parsing. And then if you wanted to do type checking, you would allocate some more memory somewhere else. And then, fill that in and then back pointer to the parse output so that you could refer to it. Right? And you keep building up this more and more of a structure. And a lot of compilers probably work that way. But because I wanted this to be fast, I said, well, you know what? There's some stuff that comes from the parser. And then there's some stuff that gets computed later. So like this thing gets computed later, this overload set, for example. Custom operator call here is something where if you have a unary operator and we look it up and we like a plus on vectors or something, and we realize it's a function, then we generate a function call for that so that later code in the compiler can just run on this function call, right? But we don't substitute it in the tree because, like I said, we don't do tree rewriting in that way, but we just put it here, and then the code generation pass knows to like look at this slot, right? And the most extreme version of this is asked expression, which I think is in this file, has some stuff. So this queued thing here is the pointer to a data structure for the compilation unit that I was talking to Casey about last time. And then, there's all this stuff like, well, what's the type? Like, what is the type of this expression is stored here? And that's only something that you know from type checking. So these nodes contain data that is both like static, like from parsing it earlier, but also generated by later phases, which if you had a single pass-through compilation model, that would be only a little bit confusing. But the problem then is we have this system where you can like modify procedures. Like, let me take this procedure that's, it's not templated in the C++ way. It's just a regular function, but I'm going to bake the second argument to be a constant, and I want you to optimize it for that, right? And so you can make a copy of that function with a sort of a compile time currying applied. When you do that, how do we do that? Well, it's the same way we do polymorphism generally in this language, which is we copy the syntax tree and then rerun the later passes on it. And so it's really confusing kind of knowing like what do we copy and what do we not copy and what gets filled in by whom. And it has caused problems in the past, let me say. And so the first thing I would want to do at some point, like I have comments on the side of these sometimes about where this field gets filled out, but the first pass on this header to help people program with, and I will say this isn't just an academic concern. So someone on the team was trying to do some functionality and they spent a long time being confused by this because like they were trying to do something with some nodes, but some data was filled in by a later stage and they didn't realize that it had to be reset in order to rerun that stage, right? There's a lot, like when you're writing code, there's just a lot of implicit knowledge like that where unless you document it very, very thoroughly, nobody else but you is going to know, and somebody's going to have to like be the Egyptologist who decrypts all these facts about the program later. So all that is just to say that the cleaner version of this, well, the first step of the cleaner version would be to have a big barrier in here between like the parse time members and then a bunch of comments and then the non-parse time members, which already has an impact in C or C++ because that means maybe you can't pack the structure, right, in the same way that you would. But then the better thing to do that actually would have a positive performance impact on some stages is to just have them in separate memory anyway, because if I want to make a different version of this procedure, I don't actually want to copy the entire node, right? I want to keep the node that you parsed because that doesn't change. It's just I want to change the output of the type checking stages in the later stages, right? And so really I just want to substitute, for every time I polymorph something, I just want to substitute the inferred data about it and just point back to this constant, like essentially read-only data, right? And it's just not structured that way right now. And that would be a massive change. Now, the thing that makes that more complicated is like, well, this dovetails with other things that are, well, let me reiterate first that the reason I didn't do that originally was because my instincts were to make things fast, right? So I wanted to pack everything in, or do everything as soon as possible. And then later I realized maybe that wasn't the right design for this compiler. It might be much more the right design for your compiler, right? I don't know. Except not, because, you know, we just said the thing about trees being hard to do SOA with, and SOA is a good idea where you can get away with it, right? But so the other problem that I have, the other piece of constant complexity in this compiler is this scheduling all these tiny compilation units everywhere. And the thing about them is you can be, you know, running along and type checking them and then run into some identifier that you don't know what it is yet. And you didn't know that you don't know what it is yet until you got there, right? Some compilers, like I believe the D compiler, uses a fiber system to deal with this. You just have like a bazillion fibers and you yield. I would find thinking about fibers in that way to be very confusing. Like I've never done it, but like there's a reason I've never done it, because I don't feel good about that. So the way this compiler works is it's cooperative. So you hit something that you don't know what to do with yet, and you say, I'm going to quote yield, unquote, but our version of yield is a cooperative yield where you just set some data that says, look, when you know what this expression is, call me back later and we can continue, right? And the problem is, of course, with a naive tree processor, you can't really do that because you're like somewhere on the stack, right? You're seven calls deep and you don't know what to do. Of course, in a functional programming language, you would do like call with current continuation or something, but that has performance impacts, right? If you do...
So do you just have to restart it? Is that the...
Yes, and the reason I do that, so, you know, like one, even if you didn't use official fibers, one temptation is to cobble together your own kind of fiber thing. Like, you know, way back in college, I would have tried to use set jump, long jump for this or something, right? And the problem is that then suddenly you can't just write regular code anymore, because you have to be super paranoid about what changed since last time that you were here, right?
Right. Yeah.
And it's very easy to make very serious mistakes that way that are very hard to find. Just like threading bugs, but different because it doesn't, you know, I don't know. I sort of lost my train of thought for a second. So what these things look like, I try to limit the number of places where you have to like re-enter something non-trivially. Like I know which things could fail and which things can't possibly fail. And the things that can fail tend to be the more complicated things, like, oh, this operator expanded out to a procedure call, and then that procedure call was using something that we don't happen to know, right? And when we do that, I expand a little local syntax tree and then go back and, okay, anyway, so this queued thing here that I'm highlighting, this structure basically has an array of expressions on it, and let me just go to that. I don't know how clear this is going to be, but I figure I should at least try to use this text window at some point. Oh, it's in this file, so that people at least have a reason that there's text on the screen. So this thing has an array of expressions somewhere. What am I even looking at? Oh no, I refactored this recently. Okay, this flattened for infer has an array of expressions on it. And a cursor that's just like, which expression are we trying to do right now, right? And so this actually holds the state. And so if you ever bail out cooperatively from one of these functions, it'll call you back like with this state. Now, sometimes what you were doing was complicated, and that gets back into this other syntax-free issue that I was talking about. So if I go to procedure call, for example, calling a procedure in this language has many steps because you have to resolve overloaded operators. You have to maybe do some polymorphing, whatever. There's like a lot. And so you have to sort the arguments because you can like name arguments. And so you have to map the arguments from the, what is syntactically in the program into what the procedure actually wants. And that's different for every overload, right? So you have to do a bunch of things. And so there's this call resolution status, which like records what we were doing. And then when you cooperatively re-enter this thing, you look at that, and this is kind of like a state machine. It has a state index, like which index of call resolution are we on right now? Like, actually, this one doesn't have that. Some other ones have that. This one, I guess, just says, look, which overload are we trying to do? And then if this cursor reaches the end of the overloads, we can look at these Booleans and decide what to do. Anyway, the point being, this gets gradually filled in, and you might yield several times while you're doing this work. And part of that yielding involves making more subtrees, right? And so, okay, so part of the whole point is to generate this array of expressions that lets me be cooperatively like reentrant. This is also a thing that takes time because I walk the tree and flatten out the expressions into an array. You don't necessarily have to do that. I did this because it was dumb and easy to understand. There's other things you could do, like you could have a data structure that represents a current position in navigating a tree, right? It contains, an array containing the parent node for where you are for n different parent nodes. You could walk all the way up to the top, and then you could like recurse into different subtrees. That still looks really ugly in something like this because whatever code walks down the tree from there has to have a different path for every branch of every data structure, like hard-coded into it, as far as I know. But that's another way that you would do it without having to do this work. But of course, that's not free either. And which one is better, it's unclear. But so if and then I'm also dealing with the fact that the type checker itself, I want to multi-thread that, right? Because that's the model for this compiler. And if I want to multi-thread type checking, that's really scary. Again, kind of for the same reason that fibers are scary, but just kind of for the regular reason of like, really complicated code that wants to look at a lot of data is scary to multi-thread unless the data is very, very organized, right? And this data is not very, very organized in that way, right? So we have these trees with like some things that are constant and some things that are not constant. And everybody wants to know what the type of the expression is, except maybe it's not set yet, right? And all this stuff. And you could imagine that if I laid a lot more things out as arrays and there was locking on certain arrays. So instead of putting the type on the node, which by the way, it wouldn't be able to be anyway if you were gonna have this be only parse data and point back to it. If you just had that in an array and this was the main thing that people were trying to hammer on, then at least you can have some strategies around containing that and making it fast, in fact, right? And so this whole compiler, maybe in order to be threaded in a sane way, wants to be more SOA to begin with, right? And if I had known that from the beginning, I might have done something very different. That said, I'm not sure it was wrong to do it this way because I have a working compiler that is still faster than most people's compilers, right? While still being a very complicated language. But I'm also looking at this and I'm like, this is not the best final design, and C++ doesn't help me get to the best final design. So that was a very long background. But I guess kind of what I wanted to say is, I have my style of programming. It's my style because I feel like it has helped me a lot. I've iterated my style over many years as I work on games and stuff. And this style has been my survival tactic because games are very hard and will kill you if you don't watch out. And But there were some drawbacks. Like maybe if I had been Sean style thinking about performance, I would have ended up in a better structure, closer to where I want to be in the end. But it also might have taken more time.
Yeah,
You know?
it's a huge risk. I think, like I've done a lot of stuff speculatively in my thing that I really don't know whether it's worth it or not. And one of the problems is that the only way to know how much value you get is implement it like the naive way and then implement it the maybe efficient way and see whether it's really faster. Um,
The
and
thing with
so
this is like that's a giant undertaking to do
no,
that,
it
right?
often is, right? And
Yeah.
so that's a problem. And so my solution, quote unquote, to that problem is just go ahead and implement it the optimized way. But that's very wasteful because if that thing that I'm implementing isn't actually the slow part of the slow path of the thing, I've wasted all that optimization effort. And a lot of the times this stuff percolates through the whole system. I'll give you an example of a bad decision I made like that.
Mm-hmm.
So so I just do this stuff, right? I just like, oh, how will I implement this? I'll implement the hard way. And and it wouldn't surprise me now if it turns out that like 80% of the times I've done that in this project is wasteful. Is unnecessary. Not that, maybe it gets a 2% speed up or something, but it's not going to turn out to be valuable. So in the preprocessor, I'm trying to minimize how many times I copy characters. Okay, so let's step back for a second. The preprocessor and the lecture stage have to deal with characters. And so there's this old rubric in compilers that those are the slowest part because they deal with characters and everything else deals with tokens.
That's what I was taught in school too.
Larger structures, right?
Yeah,
And
it's not correct.
and it's not probably true anymore. I
Yeah.
don't know what fraction, because I haven't got far enough through it. I don't know what fraction the whole thing is.
Yeah.
You have some data, but because of the way you approach multiprocessing, you're concerned with wall clock time. You're like, I paralyzed the parser so it's fast enough.
Yeah.
The other stuff is paralyzed so it's not fast enough. But if you went back and you looked at, if you were having to go through my model, I don't know how fast your parser is if you were forced to single thread it. Like, if you understand.
It's pretty fast. It's fast enough that it's not one of the things that I would be optimizing right now, even if it were single threaded.
Okay.
Yeah, but I mean, it's not like, I mean, the thing is, if something is 5 or 7 or 8% of compile time, and you want to make your thing faster, you don't ignore it. Like, that's a significant chunk still, right?
Yeah.
Like,
yeah,
this is the thing people don't necessarily get. Like, if you're working on something, again, and it's not super wasteful in the beginning, like 1% is a good use of your day. Like, that's great. I mean, if you can do 1% every day, then your program's infinitely fast very soon, right?
Yeah.
And so these numbers matter. And so even though, like, I don't even remember right now if it's 5 or 8% or whatever, and that's probably changed a few times. 8% sounds high to me, but, it's like, it's not something that I've worried about, but it's not something I would ignore, right? If I, trying to push that speed number down. It's not 0 for sure.
Yeah. So like when I said that some of these things I'm doing probably aren't worth it and might only be a 2% gain, you're correct that a 2% gain is actually valuable, but doing a big complicated, making a thing complicated all the way through the entire system is probably not worth 2%. And so I was going to give an example. And so the example is this. One of the things that the preprocessor has to do is backslash escaped lines. It has to combine adjacent lines that are backslash escape.
Yep.
And so the preprocessor has two basic modes of what it's doing. It's either dealing with regular C text or it's dealing with preprocessor directives. So the solution for dealing with regular C text for the backslash escapes is totally fine. It's optimized. It's because it almost never happens, right? So the code is optimized around the idea that it's almost never going to happen, and I can take a slow path when it happens. Pound defines, on the other hand, you often use backslash escapes. And so it's a more reasonable scenario. And one of the things I'm trying to do in the C preprocessor is minimize the amount of copying of text. That was where I was trying to go when I was saying that the number of characters is big, right?
Yeah.
So I stupidly made the decision that instead of here's what the correct thing to do is. When you see a preprocessor directive, you call a common function for all preprocessor directives that goes through and builds a new buffer that has no backslash escapes in it, right? So it goes and scans the end of the line, and at the end of the line, if there's a backslash escape, it builds a new buffer with the backslash escapes removed. And if there's no backslash escape, you can just work with the buffer that you have, so you don't have to do an extra copy. And I was like, I don't want to pay the cost of scanning that. So I'm going to have every preprocessor directive in the middle of doing its parsing, checks to see if there's a comment or a backslash escape. And if it sees one, oh, now it escapes to some code that builds that buffer. But if it doesn't see one, it just tries to keep parsing. And that means every single preprocessor directive, because each directive has like different ways, like pound define takes a certain kind of text after it, but pound include takes a different set of rules for the text.
Yep.
Pound include, you have to actually do macro expansion on. And because like you can do pound include __ file _
Yep.
for no. But so like you have to do, so it's just the wrong decision. Like in hindsight, like once I started writing, I had gotten through like writing about 80% of it. I was like, this can't be right. I bet I could just afford to take the cost of always building the buffer.
Yeah.
And the amount of complexity I'm having to put in, I'm sure there are bugs. I'm sure there are certain directives that if you put a backslash escape in a certain spot, it's not going to handle it correctly.
Yeah.
And that was more of the realization was like, oh, getting this actually right is hard. That's why it's not worth it.
Yeah.
It might save 0.5%. I don't know, like who knows, but it's clearly a mistake. And the point is that like, that's the way it is currently. I'll go back and fix it at some point, but because I know there must just be bugs.
Yeah. I mean, if it's a place, that you can get 0.5% as long as you're willing to work a certain amount, that's valuable information, right?
Right. So one of the things is, I can go back in, do it correctly, and I can compare whether it made a difference or not. That back to that old thing. But it would probably have been better to just do it. The problem is like, it's also very hard to measure that. Like you can't, if you only do this implementation, it's very hard to know how much overhead am I paying for doing this. Like you could measure that one function. Oh, here's the function to build the new buffer and see and try hope that actually reflects how much gain you would get from it. But because of the way systems cascade, you can't be sure. So anyway, the point was that was just a dumb example of a place where I know I did it wrong. And the thing is that the compiler is full of those kinds of design choices where I'm like, I can eke out a little bit here. So I agree this is probably not the right way to approach things. On the other hand, if you don't do it this way, it can be really hard to make the huge change that you have to make of something that permeates your system.
Yeah. I should actually clarify one thing too. When I was sort of poo-pooing how much time parsing takes, right? That is very different for different programming languages, right? So because yours is for
preprocessor.
Yeah, because yours is for C, you're going to be including the same file zillions of times, right? And your type checking phase is going to be way faster than mine, right? And so also because of that, lexing and parsing will take up more proportionally, right? Because like you don't have polymorphism, you don't have like meta programming messaging, you don't have even like function overloading like takes time, And I don't think does C have overloading yet or no?
They may have added it in C11 or something. I don't know.
Yeah, I don't know. But you're not doing that right now.
Yeah, I'm only aiming for C99. So
yeah.
So like there's definitely like this is, and we have different goals and they're different languages. So anything that applies to one of us is not going to apply to the other a lot of the time here. Yeah. But it's still worth talking about them. Obviously. Yeah. So.
It's just even I forget that sometimes. So when I was saying the thing about the parser being super fast, it was like, oh yeah, but.
Yeah. So yeah, I mean, I should mention I'll do this in Discord. I think I have the tweet. Yeah. Okay. So I tweeted this about a week after I started the compiler.
It's been a while since I've thought about screen sharing here. So we only have Sean's screen at 720p, unfortunately.
No, I posted you the tweet in Discord so you could click it.
Wait, why is you're watching my stream?
Yes, exactly.
Okay, so we're not screen sharing. A full rebuild of a 10 million line program should take less than a second on a modern mini core
you could actually put that up or I can put it up.
Oh, and then the one you referred to. Okay, so you want me to click on this? Well, Sean's putting it up. Well, no, I can do that too.
Okay.
If I can dude, I switched to Firefox because Chrome is driving me nuts, and like I
Yeah.
just can't do simple things correctly, like drag it to the other monitor. Anyway, WrestleMania, but Sean, uh, an opinion about programming that will get you unjustly dunked on. Did you actually get unjustly dunked on for saying that,
No,
or
only one person did. So, well, and so the whole point of the unjustly here is kind of a joke, right? Because, like,
yes,
like, yeah, I mean, because I intentionally pushed that number up as high as like a little higher than I thought was reasonable,
yeah.
to try to get somebody to dunk on me. But now I've already forgotten what we were talking about that made me bring this up. Different languages. Uh, shoot, I've forgotten the context. But it does still matter to the overall conversation. Like I tweeted this. Nobody knew I was working on a C compiler. I'd only
Yeah.
just started it,
Yeah.
and that was sort of setting myself my goal for that.
Well, I
So
definitely.
I want to try to hit like 1,000,000 lines a second with single core, but that is C. So you're going to get a bunch of includes. So the total lines of code, obviously, yeah.
Yeah, I have a target of well over 1 million lines on like a current desktop for my language.
Right.
That's a multi-core target, right? And so,
Yeah, exactly.
but like I said, I probably will have much more of a problem parallelizing than you will. So
Yeah.
I probably won't. I don't know. I don't know how well I'll
Yeah,
be able to exploit the cores, but you know when I even said, so I was at I don't know if anyone remembers this. I don't know if it was public. Maybe it was like secret invite only, but anyway, there was a little bit of a game development conference at Insomniac a few years ago,
Mm-hmm.
and it was just a cool thing where they just invited people to come down and you know, kind of. I think Mike Acton was the main organizer, and it was a cool event. But so like I was talking to people there, and it was when this language was a newer thing, and not that many people knew about it, and somebody was like, well, how. That's ridiculous not having incremental compilation. And I was like, well, no, I mean, you should be able to do 1,000,000 lines a second, right? And how big are the biggest game engines, right? They're an integer number of seconds where that integer is, if that integer is 10 or more, the engine is probably mostly wasted code anyway. But, you know, the highest ones that I've heard of are around 20 or something. And probably a lot of that is even tools that you wouldn't try to build at the same time.
Although C++ is this mess. Bruce Dawson was doing a thread about this recently on Twitter, which is that there's an n squared problem with C++
Oh yeah.
projects.
Oh yeah, very clearly. But just in terms of, well, that's part of the other thing that I guess we'll get back to. But the point was I was talking to someone else who was also in video games because it was a video game thing, and he thought that number was ridiculous. Like that it was absurd for any language because he didn't know that much about the language that you could compile that fast. And I was just like, okay, wait. How many triangles per second does your GPU do, for example, right? And it's like, okay, that has hardware assist, but like that should calibrate to you how much work your computer can do for some definition of work, right? And why is your expectation for compiling lines of text like many orders of magnitude less than that?
Yeah.
It just, I tried to use analogies like that to recalibrate people's expectations because again, our superpower is that we're old.
Yeah.
And because we're old, we know how fast things should be. Whereas people who are young, like human beings learn by example, right? You learn how fast something should be because that's how long it always took computers to do that thing every time you did it. And so if all the programming language that you compiled, like if you were lucky to get remotely interactive speeds, anytime you did something with your computer, then that's how fast you think a computer is, right? And that's the situation that we're in. And I think that's part of why it just keeps getting worse is because, well, I don't know.
Yeah.
I can go on forever about that.
It's a feedback loop. Yeah.
Yeah.
Anyway, so I guess maybe the reason I brought up the 10,000,000 lines of code thing was because I was talking about the includes, that I do have to parse the includes as well. So
Yes.
that all kinds of adds up. So I do actually have a plan, by the way, to put in a module system. That's one of the experiments that will allow us to minimize header dependency.
Yeah, it's probably going to be ugly, but it is what it
Ugly
is.
syntactically or coding it.
Just in that way that like caching things is ugly, right?
Yeah, well, like one thing you could do is so like a module system where like I think of the OCaml system in my head for some reason, but so
Yeah.
like if you think of a module system as like basically there's kind of a header file, but it's a binary that's generated by the compiler,
Yeah.
and you don't have to rebuild it if the interface doesn't change, and you have some way of specifying what the interface is. One thing that you could imagine is that you just always do a full rebuild um, uh, of the module bins. Like, so you always go over every file and regenerate the interface binary. Like, don't cache that. But and so it just like is like, oh, I don't need to rebuild the O files, and I don't, and I always, but I do have to parse every C file to do at least up. Like maybe the interface is only at the top of the file, and you don't even have to parse the whole file. I don't know.
Yeah. Well, so one thing, we have a bad version of that historically, right? The Visual Studio precompiled headers, which still to this day, there's super broken stuff about those that they haven't ever bothered to fix. But, one of the things about them is they've never been that much faster than non-precompiled headers. Like they're a little bit faster usually, but like not night and day difference. And so do you have any idea like why that might be aside from just those programmers not knowing what fast means?
I don't like. I had so many other issues with precompiled headers that I don't even know if I noticed that issue. Like
do you just turn them off all the time or what?
Yeah, I just turn them off. VC6 defaults them on. I have to remember for every project to turn them off.
Yep.
I mean, so the thing with the module system is that it doesn't prevent you from being quadratic. Like if you depend on other modules, you still have to like load the module binaries or whatever, right? It just means you get rid of parsing and stuff, and you don't need abstract syntax trees if you're loading are declarations. I mean, you can imagine that you have something that brings those in a way that you have some internal representation of a function declaration, and so there's no syntax there because it's just declaration.
I mean, you could imagine, just you have an array of declarations serialized and they're like constant size. Maybe they point to some non-constant size data at the end for like names or whatever, and you just load them in and you fix up pointers, or you don't even have pointers because they're offsets. I don't know. You could do something very fast there for sure. That I'm sure is much faster than what the Visual Studio people did.
But I mean, precompiled headers try to work without changing your source code, right? And the module system is definitely going to be like explicitly export this function kind of stuff.
Okay, so it's an extension to the language.
Yeah, sorry, I thought that was clear from that term because people have always been talking about putting a module system into C++, and it involves actually like changing the language.
I thought so, but I just wanted to be sure.
Yeah. No, absolutely, for the audience, clearly.
Yeah.
Anyway, so there are things that I can do about that include problem, but I want to. The starting point is get the full build, C standard thing, and get that as fast as possible. So we were talking about that programming style thing and how that impacts it. Do we want to? Have we beat that to death? I guess.
I don't know. I mean, I feel like there's an infinite amount of stuff to say.
I mean, I think we both just acknowledge that each other's approach might be better sometimes. Like,
I mean,
great.
Well, ideally, you want to be able to, like my particular style has many sub-styles at this point, right? And
sorry, I leverage once in a while, and that one I lost.
Oh, I was just saying, like my particular style isn't exactly one thing. Like I use heuristics in my head about exactly what to do, like exactly how far. Oh, and the one thing I did want to say, and this is a point that I want to make a lot, right? Like, so my style is, in my mind, about just making it tractable somehow to write all this software because it's too much work. It's so hard.
Absolutely.
And just like having something that at least kind of runs for a while, to me is very valuable, right? However, there are other factors that matter, right? If you're unhappy with what you do every day, you're not going to be as productive, for example, right? So that's like a factor that has to be recursively included into this computation. And so one thing that happens, especially on a big game, is like I just start working on it every day and I'm like, oh man, like everything here sucks. You know, I'm doing all this code. It's not structured the way that I know it needs to be in the end. It's not that fast. I'm not really proud of anything. The game looks crappy because it's not that far along. You know, there's graphics effects that are not that important right now in objectively, but they just make me feel bad every time I look at the screen. Like these things start happening no matter how well you manage your own psychology, right? And so at some point, I think it's actually worth a lot in a big project to just be totally irrational about what you're going to work on now. Like, look, I know what the priorities are on paper of what needs to happen when and what is blocked on what, but like, I just don't feel good about this tree flattening thing over here or whatever piece of it. This isn't exactly the thing I feel worst about in the compiler, but I'm just picking that as an example. So I'm just going to do that now, even if it means I don't objectively make progress for a week. Like I will feel good about this. I will have this feeling of doing good craftsmanship, and I will be happier about what I'm doing as long as I understand that like this is what we're doing now. We're toggling into a good craftsmanship mode where I don't actually care that much about reaching the end goal as quickly as I otherwise would. I'm just kind of chilling, but I'm kind of doing the best job as I can on this little thing. And that for me has been very valuable sometimes. I don't do it that often, but when I do it, I really do it.
Yeah, I think to some extent the premature optimization that I do is a morale thing. It's like I like doing it, so I'll get more done if I do it. But it definitely does have this consequence of, like you said, just being able to get the whole program done. Like I make my life harder in the long run, so it is. I mean, my worst experience with that is with Iggy, the garbage collector stuff, which Jeff talked about on a podcast in a way that was not accurate to what he was talking about. Why garbage collection was bad based on our experience, and he was talking about what I'd done and wasn't really accurate. The issue that I had was that I was writing the library for a garbage collected language, but I was writing that library in C. And so I had to interact with the garbage collected stuff natively in C. I didn't even have C++ operator overloading, like scoping stuff to help. And so I was having to constantly say, lock this pointer, and the garbage collector was a relocating garbage collector, so I had to always reload the pointers after every single operation. So like I had a coding style rule that every function call would end in _GC if it might trigger a garbage collection and might relocate things, so that I would always see in my code, oh, there's an _GC, got to reload that thing. And that was just incredibly bug prone, but I don't think it was a mistake, because I don't know how else I could have written the code base. Like I needed the stuff to be relocatable so you could defragment memory, like a bunch of constraints on it. It was a total nightmare. And when the / escape example of the preprocessor is that same kind of thing, but I'm just doing it to myself for no good reason. At least the garbage collector was a nightmare for a good reason.
Yeah, I've seen that problem, that bad ergonomics of interfacing with C. I've seen that problem kill projects before. Like, I think, so when I was in a contractor for a little bit at SGI, there was someone who, like, we were making this little desktop environment for set-top boxes, and somebody was like, let's make Scheme be the extension language, and that'll, whatever arguments you can imagine
right
about how great that'll be. And I didn't ever see exactly what was happening, but my impression was it was just crashing all the time because he wasn't able to deal with all the GC moves correctly, So, yeah.
It was the number one source of bug reports from our customers. Was that particular issue, the C source code dealing with the garbage collector.
Oh, so even after, or was this with them trying to write things that interfaced
No,
as well?
it was my code. There would be like the code would look fine, and
Yeah.
oh no, there's this. If you think about it, this thing is loading this thing before the function is called, and is actually not reloading it, but it's subtle the way that that's failing.
Hmm.
Just stuff like that. And there were just no tools to. Like I said, if it were C++, maybe I could have figured out a way to smart pointery kind of way to do better. But yeah, it was just a mess. And the point is like it wasn't the end of the world. We didn't have lots of bugs, but it was the number one source of bugs. It was like 50% of bugs probably.
Yeah.
So yeah, don't do that to yourself if you don't have to. Is a pretty good rule, I think. But it's so hard to. It's just so hard to know. Oh, I'm going to do this crazy thing, and maybe that's going to be a performance win. It's
Yeah.
yeah. So.
Well.
So yeah. So but anyway. So yeah. So I think the part of my style of doing that is because I enjoy doing it. So
Yeah.
like that's and that means I'll get more done than than if I, even though it makes my life harder in other places some of the time, I still will get more done probably.
Yeah, I would encourage people not to underestimate that factor. Other things, so like Go, for example, has this Go format thing, and I guess other languages are doing that. Like I guess Rust maybe has that too.
I got to drop out of what the thing was.
Oh, Go format, Go FMT.
Oh, yeah.
And the idea, I think it's a really mistaken idea, but the idea is that like arguing about, coding style is such a, productivity drain that we're just going to declare what it is standardly, and then we're just going to have tools that assume that that's what it is. And so you conform, and that's just what you do in this language. And like, I kind of understand why they thought that, but the problem is, like being in your code is like being in your house, right? Or whatever. Like if you can't put up a poster on the wall that you want, it doesn't feel like your house the same way. And so my style, my personal coding style has a lot of aspects to it, right? It has what I do when, it has like what kinds of names I pick for variables and how verbose they are, and when I allow myself to use single letter variables and when I don't. It has, how many spaces go where, and all these things, or when do I insert blank lines, and all these things are just things that I've developed for myself over time that are more comfortable to me, right? And I don't expect them to be the best style for anybody else, but like if I absolutely had to program in somebody else's style, just syntactically, right? Clearly I can do it. Like it's the same programming language, but I just, I won't be 100% happy. Right. And so I feel like subtracting that is a mistake. I don't know. I don't know what you think about that.
Well, okay. So here's one of the things. I don't know how much this is true for you. I think it's probably somewhat true. I'm a solo programmer. I'm the only person programming my projects. So my opinions do not really apply to most people who are working on a team. And this is an example of a place where that's a big deal. Like there's no reason for me to use something like Go format because like I'm the only programmer.
Yeah.
So like my opinion on all sorts of subjects like that is just totally irrelevant. Now you have other people working on your code, but you sort of get to set the direction of things, set the base style. So
yeah, I mean, it's different. So, so far at the company, this might change as we get bigger, but so far we just hire people who can deal, right? Who don't need micromanagement. And then they can just do whatever they want stylistically, right? I mean, unless that style involves something terrible, like doing 1 trillion heap allocations everywhere or something, but that's, you hire people who understand that that's bad. And for the most part, it's just fine. You go look at someone else's code and it's like, yeah, this is different. And I don't feel 100% comfortable here, but again, it's the same language I usually use, so they indent differently. No big deal, right? And then there has to be a little bit of a curb your own impulse to like gratuitously change somebody else's code just because you went in to read it and like fix one small bug. Like if you kind of reformat it, then you're being a jerk, sort of.
Yep. Yeah. Of course.
And so don't do that. But other than that, it's fine. And like if I were to take over a piece of code, I might feel free to reformat it and whatever. That's how it has worked so far, and it's mostly fine. But again, mostly people are able to go off and work on their own subsystem, you know? And so I'm not sure, like if there were 20 people working on the same function, right? You would probably have to pick a style for that function, but
Right. Yeah. So I guess I want to clarify because, well, it's not even clarify. I want to correct myself. There are two levels. So the first level I described is it doesn't matter to me because I don't have any other programmers on my project. But secondly, I don't actually have enough experience to even have an opinion of what it should be like for other people. I can't tell you whether Go format is a good idea or a bad idea. I'm just out of touch with that world.
Yeah. Well, I mean, you know, since I sort of have to decide what's the philosophy of this programming language as it extends to tools and stuff, because that determines
absolutely
what, you know, I sort of have decided that that's just not the business I want to be in, is telling you how to indent or whatever. You know, who knows, that might be a mistake or something, but I don't know. Don't feel good about that one. I just like, I like my code to look how I like it. And therefore, so one response might be, I'm going to make a format program that makes everybody's code look like my code. Right. But that would be a very childish solution. Yep. So, yeah.
There is one thing that reminds me of.
Yeah.
Like sort of the Go format, maybe the argument, I'm sure I read what their argument was and I don't remember, but
yeah.
It's sort of like it makes it easier for everybody to read everybody's code because it just comes in the way that you expect. I mean, obviously any individual organization could try to institute code standards. You don't need the language to do them. But it seems like they must have had some argument like, hey, this just makes it consistent for everybody, and that's better for code sharing or whatever. Like,
yeah, that's the idea.
Makes tutorials better, or that kind of thing.
Yeah.
Shoot, I totally forgot where I was going with that.
Oh.
Oh, I'm so old.
Well, that's just where we're at these days.
Yeah. All right, let's just move on. I don't remember.
Well, okay. So back to the speed thing, because I don't want to talk about syntax forever, absolutely. Because that just invites everybody to rat hole about meaningless things in chat. So, but on the topic of making a compiler fast, so if you've got all these trees everywhere, and you've got something that sort of traditionally wants to be all these trees, how do you make it more SOA or data oriented or whatever? So one example that I have, right, is like, well, I wanted to separate into like parse and post-parse data, right? So those have to be correlated in some way. And so maybe as I parse and I allocate each node, maybe each node just has an index that other people can look at. And if you wanted to make an array of like what the output of the type inference engine is for all these nodes, then you could just have an index back into this linear array, right? And that tells you. But the problem with that is it's not totally linear, because like I said, if we're doing like an operator overload or something, you kind of want a subtree now, and maybe you tack that onto the end. It just suddenly starts not seeming that efficient or not that nice, you know? Mm-hmm. So I don't know what you do about that, or how you think about that.
I don't know. So what's the scenario? Wait, what's the pointer? Oh, right. Yeah.
I mean, you could just imagine, like, if I wanted to compile, if I have a generic function, right, and I want to compile 3 different versions of it with the argument being different types.
But, so I guess there's an argument there, which is especially when you're multi-threading, it's maybe just better to always copy the whole thing.
Well, if it's read only though, it doesn't matter, right?
No, but maybe it's just because maybe it's better to make it not read only and to just copy it.
Maybe. I mean, I don't know, right? But I'm scared of that. I'm scared. So the making it not read only is part of the thing that's scary, right? Because if something is read only, then you know you're not going to have a threading problem there.
You're cutting out hugely now. Can we?
Oh,
maybe
I'm sorry. It might be my noise gate actually, because I was kind of leaning way back.
Oh, do you have a separate? Do you have your own, or it's the noise gate in the Discord?
Dude, there's like 17 noise gates on this computer
Okay.
right now because there's Discord, there's OBS, which wouldn't cause problems for you, but other people. There's at least 2 built into Windows that I know of, right?
Are there? Okay.
Yeah,
Discord, you can't set it. You can only set the level. You can't set a separate noise
oh,
gate.
there's not a noise gate. That's weird.
Or at least my version of Discord. I don't know. Maybe I'm on an older version.
No, well, there's automatically determined input sensitivity. Oh, but that's for voice activation. I don't know, man.
Yeah, it's input sensitivity. That's just you can either set manually or you can set it automatically. So
Well, it says automatically determine. Okay, no, there is a noise gate. If I turn off automatically determine.
no, that's just a manual input level. There's not a separate.
No, I don't. It looks like a noise gate, man. I don't. Anyway, I turned it down. Maybe that'll help.
Testing. Oh, yeah, maybe it is a noise gate. Okay. Hey, sorry. Can you start over?
I don't remember now. I just remember talking about the noise gate.
We were talking about the why you don't want to copy the stuff in the.
Oh, well, yeah. I mean, if it's so part of my problem is I have this node and different things are written into the node by different stages of compilation, right?
Right.
And other stages, of course, want to read those things. And,
Well, so okay, there's
yeah.
this state machine model for multi-threading stuff, like where you treat the state of some little set of variables as a state machine, and so you always know what states it's in. There's a really simple model where like something is either null or it becomes non-null once.
Yeah,
And
and that's
if
the
you-
way most of this data is, I think.
So like if you could formalize that, I think it could be. Like I'm very sloppy about that kind of stuff, but I try to avoid multi-threading as much as possible. So my thoughts on this may not be the best, but I think if you really can like rely on that kind of model, then just copying the data is copying when you do the specialization.
Yeah, I mean, the problem is that I'm programming in C++ right now, right? And so I could say things are that way, but I don't actually know how to get any kind of help with that
The
without.
barriers and all that.
I mean, there's probably some really, really horrific template thing that I could do, but it would kill both my compile time for the compiler, and it probably would make code generation much worse. I don't actually know that for sure, but it's quite often what happens. And I just hate templates so much that, well, but for all the usual reasons, really, many more than those two, that I almost am just not willing to go there. Which is a shame.
Yeah,
I mean,
no,
I
yeah.
almost want to just like write a preprocessor or something. Like I want to do, so in my language, I could do things like, hey, this member of this struct can only be accessed from the following files. And you put in a whitelist, right?
Yeah,
and
yeah.
I mean, you could sort of do that. I guess to do that well, you would have to make like a compiler extension in LLVM or something, which I don't want to be in that business either, because now you're maintaining tools, which like I'm not trying to ship tools for C++. I'm trying to ship my own freaking thing. But like maybe a really crappy just thing that doesn't even try to look at the syntax. Maybe it's like literally if
Right,
you use if you use this string in any other file, we will fail you, right? And I wouldn't even have to run that every compile, right? It's just like check it once a week or something. I don't know. I haven't thought about that very seriously, but something like that could help enforce something like that.
Yeah, I mean, yeah, multi-threading is just hard, and I have just avoided it. So that's definitely why the single-threaded compiler is what I'm doing.
Yeah, I just don't. I mean, again, for you, it totally makes sense, right? But I feel like we're in this situation where, like, a lot of people in the programming language world are using that model where, in cases where it would be better not to,
Yep.
because they're afraid of doing the thing that we shouldn't be afraid of. Like, if we actually had better software technology, we wouldn't be as afraid of this as we currently are.
Yeah.
And, you know, again, all the solutions for multi-threading that I've seen people propose in their programming or seen them implement are all, well, they usually degenerate things to like toy multi-threading, right? So like, you know, in Go, you could have your Go routine and you copy all the data that goes to the Go routine, which is fine for low performance threading. Like if you just want to, you know, run a process and wait for the result or something, or the equivalent of that with a thread. But terrible for the kind of things that video games do, right? Just really, really bad. And I guess even in Go, they're starting to do other things. That's what I heard. I don't know. I don't know much about Go. I just heard that people are realizing that's a problem. You know, in Rust, you can only do threaded things that are expressible, you know, within the static checking constraints that they give you, which again, they say, oh, it's fearless concurrency or whatever, but I'm just like, that's a super duper big overclaim. Some simple types of concurrency, again, it helps with, but if you're going to do like high performance stuff like you would do in a game, it starts falling apart really fast, I think. Again, I don't have super Rust programming experience, but like I look at the things that they say, this is how you do concurrency, and I'm like, that doesn't look like what I do most of the time. So, like just for example, if you want to do an atomic add somewhere and an atomic subtract somewhere else, good luck, right? Rust will not help you with that. So yeah, I don't know. I think, and so that's one of the language semantic things I'm working on. Oh, since you lowered your noise gate, we're getting a lot more keyboard and eating noise, by the way. So
Sorry.
no, that's just, it's fine.
I
It's
accidentally
just, this is
tweaked it.
what we're dealing with.
I didn't mean to.
Oh, okay. Well, I'm not sure that you actually tweaked it then. Maybe you're just
I
closer to the
did.
mic or
I
something.
did because I toggled some.
Yeah. Anyway, though, so that's a thing that I'm thinking about, and I would love to do a lot more work just in that direction. Like, how do you help with threading? But it's just hard. Like, I got to get the compiler to the step before that, where everything's done, right? But it just makes me more annoyed that I'm still using C++. Where are we at? Are we out of things to talk about? We're at the 2-hour mark almost, but
we have 10 million things we could talk about because we can talk about the details. And so, yeah, by the way, the noise gate change does seem to have fixed it.
oh, that's good. Okay.
I thought it wasn't. I thought it wasn't when you were being quiet that was dropping out, but I guess it was. Let's see. Yeah, so Casey, I was talking with Casey in chat while you were talking, and just because I had said the thing about I'm only single threaded, and he's like, well, that's not great. And I was like, well, you run multiple processes. And he's like, well, if you use the Unity compile, the Unity build where you put everything into one translation
Then
unit,
that doesn't help you. Yeah.
then it doesn't help you, and compared to a multi-threaded compiler. And I'm like, well, you're right, but there is no multi-thread. Like nobody's going to write the multi-threaded C compiler. Like so, like the amount of effort I would have to do that probably puts it. I mean, I don't know. I might have to do it because, like I said, we did talk about trying to do the Jai style thing, but it's such a nightmare. It's so much simpler when I don't have to worry about those issues.
That is true.
But,
okay. Do you want to
ahead.
soliloquy for a couple minutes? Because I actually just hit this moment where I got a little tired, so I'm going to go grab some caffeine and stuff.
Sure.
So just talk to the people out there for a minute,
Yep.
and then I'll be back.
Yep. I am reading chat, by the way. people, but when I'm talking, it's very hard for me to read chat. And like I can listen to John and scan and skim chat, but it's hard for me to do it while I'm talking. So um anyway, since people keep coming in and have missed the original thing, I'm writing a C compiler as an experiment for Red. It's not something we are planning to share with anyone because we don't want to support it. Um, so uh, the reasons for it are complicated, and because it's an experiment, it's not super worth going into details. And it's just the one bonus thing is that I'm trying to make it compile very fast. Um, that's why it was relevant to what we're talking about here. Is there something else you wanted to add about this Mike Acton talk? Oh, I'm super behind those Mike Acton talks. Uh, in general, it's frustrating when people are kind of like, oh, that's the solution, and you're looking at something where um, you just can't apply it, and because he kind of often presented it with this attitude of like, you can always do this, and you're dealing with something where you just can't even come close to doing this. Uh, so I have a whole bunch of specific things I can talk about what I do to be fast, except as I said, they're mostly speculative. Um,
I think that's fine. I mean, for me, there are some things I do to be fast, but they're mostly kind of simple and not pursued to the end, right? So like, like it's a pretty fast compiler again compared to a lot of people's compilers, but it could be way faster than it is, in part both due to thread utilization and just laying out the data better and not doing some of the stupid things I do and all these things, right? So yeah, if you want to talk about your speculative stuff, I guess the last thing that comes to mind that I wanted to say like an hour ago when we were talking about stuff, and then we just had so many things.
Yeah.
We were talking about doing things that were big restructurings on the code and how hard that could be, right? But you got to do it, right, if it's the right thing. And the thing I want to say is, at least those things are kind of feasible when the compiler is of a scale that one person can work on it, right?
Yes, absolutely.
If something gets to the size of LLVM or something, like you ain't changing that. It's just not. I mean, I guess occasionally LLM, like they rewrote their pass manager or something a couple years ago. Like occasionally large changes can happen, but they're very limited. And there's just something like size of software is pretty much guaranteed to be inversely correlated with quality, because once it's past a certain size, you just can't really manage it anymore. And the problem that we have, in addition to software getting slower over time, it's just getting bigger over time. Like all these programs are getting bigger and bigger and bigger. And I think that inherently means they're lower quality, because who can deal with all that, right? And so this is sort of, again, a plea for all the people out there. Like we kind of need, I mean, let's bring it to current events, right? So the whole coronavirus situation is showing, for example, that hey, we have institutions that don't appear to be competent at their job, like very large and very important institutions. Seem to be blindsided or taken by surprise by things that like I knew in January, or like, not taking responsibility of the things that they're supposed to have responsibility for, and not doing the work that they should have been doing, right? And I mean, I'm hoping that we can have some kind of cultural realization that this is a bad thing, that this is happening society wide. And it's just that, like, I feel like we've just had it too easy for too long. And that includes in software. So software has been too easy for too long for different reasons. It's because computers kept getting faster, and because whatever money was out there from internet companies usually happens in a relatively, like, you don't need to have quality to make the money, right? And so I would like for there to be a group of people, and maybe it's sort of like the handmade thing, but I feel like that's a little bit different even. Like there needs to be people who are like, look, for the sake of software being reasonable, it has to be kept from like inflationarily expanding into infinity, right? Like that has to be a fundamental engineering tenet, regardless of whether one person makes it or a group makes it, or whether it is allowed to use, all of, whether it's allowed to use pre-authored libraries off, GitHub or not, right? It's a little bit of an orthogonal thing, just this aesthetic that code shouldn't be bigger than it should be. And Devin said scope creep, but scope creep is only part of it. Like, it's not even scope creep. It's just for a given definition of what a program should do, programs are getting bigger and bigger these days. And it's just because more and more like self-canceling, self-negating busy work is inserted into the middle of the program. Anyway, that's my rant. You can all feel free to agree or disagree with that. But so Sean, I don't know, what are your big, so if you say you've been thinking about things that architecturally will make it fast, I mean, there's probably some kind of a mental list of which ones are the most important and which ones are less. So
yeah, and
what
there's
do you think
also
is the
which
most
ones are
important?
easy to talk about. is
Oh
the
yeah,
other thing.
yeah. Should I screen share you for a bit? We haven't done that yet.
Well, in a moment, I actually want to tangent on something. This is just a random thing I've been thinking about. I keep running into this pattern and kind of thinking about it. So, and I just had a thought. I don't know if you've ever heard this. Somebody, maybe Andy Glue, somebody had a paper or talk or something where he talked about the idea that speculative execution on a CPU can sometimes be viewed as like a sort of software prefetcher, where the idea is that we know we're going to not actually execute any of this code that's being speculatively executed, but it is going to trigger a bunch of loads, and those loads get queued up in parallel, and eventually the speculative execution fails and rewinds, but all those loads got executed, and some of them may have been correct, and so you get some performance through that way.
Yeah.
Like, which is a different way of thinking about what the point of speculative execution is. Because traditionally, you think of speculative execution, the point is like, well, sometimes it was the right choice, and you get the win of having executed the code.
Yeah.
So the pattern I've been thinking about sometimes while writing this code is I'm like, I really would like to be able to traverse this thing that's going to be kind of randomly scattered memory. And it would be nice if I could prefetch it, but it's like a linked list kind of scenario where you can't prefetch two things ahead.
Yeah.
And I'm like, it would almost be nice if I could just have two threads on this core, and the one thread gets devoted to trying to prefetch for the other thread. It just like is trying to run, a little bit ahead, 10 pointer links ahead or however many ahead, and it's trying to be smart and know what's going on. And it's just this bizarre pattern that might make sense in some circumstances, which I just think is kind of amusing.
I mean, I've thought that before, that we might end up doing weird stuff like that in certain futures, like, because using the cores in the traditional way is just hard.
Right? Yeah, exactly. That's part of it. It's like, oh, that'll, that's a way of using a core. You like maybe can share most of the code. You just have like a disable, don't try to do the work or something.
Yeah. The question is just, do you need to be power efficient or not?
Yeah. So that's the thing I want to actually get to. So there's a couple of assumptions we have in our. So now that I'll talk about some of the optimizations that I do.
Sure.
Again, speculative optimizations, don't know that they're a good idea. Some of them are almost certainly not good ideas.
Mm-hmm.
So our assumption is that compiler is running on big iron. It's a in the modern sense, it's a desktop machine. We don't care about power, beyond when that becomes a trade-off of turbo or whatever. It's the intention is that the compiler runs in 64-bit mode only. Like, I don't care about compiling the 32-bit. I actually still develop it in VC6, so it's running in 32-bit mode most of the time. But any performance measurements I do is only on 64-bit. And the reason we want to use 64-bit is it's got twice as many registers. However, 64-bit pointers use twice as much cache.
Yep.
So maybe That's not the right choice. So what I do for this is I use indices everywhere instead of pointers. I use 32-bit indices.
Yeah.
But thinking about it, what that ends up meaning is that I have a bunch of arrays that are in like there's a context structure, and I always have to keep loading those pointers out of the context structure, and those take up registers. Like if I'm in a loop doing stuff, it's going to probably it may try to register allocate some of those, and maybe I'm just using up the registers that like the extra registers I have. Maybe I'm using them up on these array based pointers.
Even so, though, like spilling to local cache is not that bad, right?
Well, and the nice thing about the x86 is that like it's got all these memory instructions. Like,
Yeah.
so if it has to reload the array bases from the context frequently, that's fast. That's going to come out of the L1 cache. Although I guess L1 cache isn't even single cycle these days. I don't know.
It's probably
So-
like 2. I don't know.
So yeah,
It's
if
not
you want
that
to
slow.
screen share,
Yeah.
let me move this.
So
Let me-
we have Sean's. This is the best image quality that Discord is able to deliver to us for a resize from Sean's screen, which is you're at 4K, right?
It's actually 1600p.
Okay, Sean's at 1600p. It's being downscaled to 720p because that's the biggest Discord will let you do. And then it's being upscaled to 4K on my screen. And then it's being downscaled again to 1080p through my Twitch. And so this already looks terrible to me maybe the downscaling back to 1080 makes it look better.
I just bumped the size up a bunch. It's
Yeah.
way too big, but that's just because there's so much resampling going on there. Hopefully
Yeah. It's at least
that will help,
readable.
despite being silly. Okay, so one of the things about using indices, so I have a project we killed that I was doing in Iggy 2, and in that I was making a lot of things be 16-bit indices into arrays for the same reason. Like I was like, well, who needs more than 64,000 items on their HUD? So I can limit all these things to 16-bit and pack these structures really well. So I have some experience with trying to do that. And so where is this going to be? Is it base types? It's base types. So I have a whole bunch of structures here that are just 32-bit indices.
Yeah, and so here's the thing. Let me ask you a question. Maybe you'll
Sure.
get to this, but if I'm trying to think, this is one of the schemes that I've thought about. Because yes, pointers are big, right?
This
You
is,
prefer
by
not
the
to
way,
have them.
because somebody asked, this is rad code, and I got permission to stream it the other day, so I feel like it's fine to talk about it.
Okay, good. So, in my case, I have like something that I kind of could flatten out if I'm talking about the nodes that come out of the parser, except it's like mildly hierarchical because I do have other things that I want to expand out after that initial flat array, right? And so, if I want to think about how do I use a flat index for that, I mean, either you could have it be two-part, like a two-part hierarchy index where some bits of it are like, which sub piece. And then, of course, you end up in these situations where you need both of them to be big for various pessimistic cases. And then it has to be more than 32 bits, right? Or it could just be more expensive to use it. Like I could imagine some case where, like say I know how big my flat primary array is, and then the secondary arrays that get expanded later just have indices that are off the end of that. So as long as it's in the primary, it's just a range check plus a subscript. But then if it was past the end, then I don't know, do a little bit of a tree search or something. I mean, I imagine that could be pretty fast, but then as soon as you're doing a tree search, it's not necessarily that much faster than a pointer.
I would never want that. I'm trying to definitely make this all pointer stuff. So the whole thing with indexing is obviously that the x86 instruction set or the x64 instruction set has a register plus register. So if you have the array-based register plus another index, it can index that fast up to 8 times or 16 times. That's because it has the register plus 8 times register. So for small structures, you can do that. What a lot of these are actually basically byte offsets instead of flat arrays. So anything that's variable sized, like the abstract syntax tree nodes, are actually allocated from a single. The abstract syntax tree nodes are allocated from a single array consecutively, but they're variable sized, and I store the index is just the byte offset from the beginning of the array.
So it's variable size for cache efficiency and stuff, or
Yeah, you don't to not so yeah, so and some of these arrays are fixed sized things. It's a mix of things.
yeah. It's just my structs are so freaking big that I don't feel like the padding at the end matters, but maybe that's just a sign I need to make them a lot smaller.
So Cliff Click, who I mentioned before, had a kind of influential paper called, well, it wasn't called Sea of Nodes, but he introduced a concept called Sea of Nodes, which was and a particular kind of intermediate representation that's different from three address code, and it's an SSA form. But the main point was that he just had, for the intermediate representation, a bunch of classes, C classes, that were very compact. Because what he said was that running the optimizer, because this was JITting for Java, running the optimizer, keeping the performance up, the best thing to do is make all the structures as small as possible so the entire function that you're optimizing fits in cache. That was his
Yeah.
and so one thing he said, and so everything used direct pointers, he said, because he was 32-bit, and that was the small thing.
Yes.
And so, yeah, in this, it would have to be. But I haven't done the IR at all. This is actually abstract syntax tree stuff. But by the way, my abstract syntax tree looks a lot like yours, right? I have a whole bunch of different structs for each type. They are all different sizes, and they all inherit this A base.
Yeah, it's just a thing that you do, right?
Yeah, right. Like, and so then when I'm allocating them, yeah, I don't allocate them in a fixed size array. I just try to keep them compact. And that is, in fact, one of the first things I wanted to mention as an interesting structural choice that might be the wrong choice, because maybe I don't need this to be that compact because everything's allocated sequentially. So when I go through it, the hardware prefetcher is going to be working, and so maybe it doesn't matter how big they are. So maybe I could be using pointers or whatever.
Well, I mean, there's a question. There's like two cliffs, right? There's the cliff of, oh, it wasn't in cache, and there's the cliff of, we're blazing through this stuff that is generally in cache, except we're out of memory bandwidth because we're going through it so fast and there's too much padding, right? And so that second one seems not that common, but like, I mean, that is the kind of thing that several programs written at RAD do worry about, because RAD actually makes software that's fast, that most programmers in the world don't even know that that's a thing, right? So,
yeah. Well, and so, right. And so I just err on the side of, well, I'll just make everything as small as I can think of how to make it small. And so, for example, this base that everything inherits from is this. So you can see all these things are byte packed. There's a union. So you either get a count or you get flags.
Yeah.
And where was I going with that? Gosh, dang it. What did you just say? You said, oh yeah, people don't, yeah. So, right. So I just make everything as small as possible because I don't know what the memory behaviors are going to be. And it's really hard to measure those other than to implement it both ways. So I just do it. If you compiled the program as 32-bit on purpose, could you leverage the 32-bit pointers for space savings? Yeah, we've talked about that. Because all of these things are in these structs, so they're hidden, and you have to go through macros to access them, most of the code could actually compile if I switched them to pointers, and we could see what the performance would be if we did that.
Well, the pointer thing that Casey just mentioned in chat, though, is totally a thing, though. You have less than half as many registers in 32-bit because some of them are hard-coded for things.
But I was saying maybe those registers are getting used up on storing all my array bases. So it's hard to know.
Yeah, I doubt it, but who knows?
Yeah. All right, but so here's the crazy thing that I do with the abstract syntax tree. So you know how like if you do like a quad tree traversal octree traversal on the GPU or whatever for ray tracing old compute style or whatever before the RTX stuff.
I've never done that, but I could imagine but you know kind of spiraling situation.
Well, but there's some stuff where like people store that kind of tree implicitly, where they just store the tree depth first or something like that. You know how to get to the next node, the next child or whatever implicitly, because you know the way the thing has been packed.
You mean if there's only one traversal order for the tree,
Yeah, well,
but then it's just an array, right?
so there's a
Or
version, right? Exactly. There's like, I don't remember the details. I just know there was a thing like
yeah.
that. So what I do in this abstract syntax tree is, I store pointers, well, indices, to all of the children except the first child is always immediately in memory after the
Okay. Yeah.
the thing. Um, which then means when you're accessing it, like you going into accessing a particular node, like, here you have the if, then you access the expression for the condition here, you access the abstract syntax tree for the else clause here, and the then clause you have to access in a different way because it has to be located next in memory. And that just permeates through the code again, because now you have to know that, oh, there's this implicit then that's the next location in memory. And which is gross. Like, I don't know if that's the right choice. I don't know if that little extra bit of saving that extra 32 bits per node is worth it. It's just, I'm like, well, it might be worth it. I'll do it now, because if I don't do it now, I don't think I'm ever going to come back and try to add it.
Yeah, you just kind of have to see how much trouble it causes, right?
Right, exactly. And that was the example of that was the point of that preprocessor example, is like, this is causing a lot of trouble. It's clearly the wrong choice.
And this whole this followed by then that you have here,
Yeah.
that's clearly a comment only for you, right? Like nobody else in the universe is going to have any idea.
Yeah, I'm
they
going to
read
have to
this.
go back through all of the comments in this, because it will need to get maintained by somebody at some point, most
Yeah.
likely.
Yeah.
I am going to have to go through and clarify all this stuff. There is like a big block comment somewhere describing the basic idea, but
But again, like why write that out if you might take it out later, right? Like you might just end up having then be explicit if you change your
yeah.
mind.
So I
and
don't
then-
do so I do the
Yeah.
simple version just for me. Yeah,
Yeah.
absolutely. So there's a few other things. One thing is, like, I wrote this originally and I had all these arrays, and I had to reallocate the array if it got if it overflowed.
Yeah.
Because, and a lot of these are very simple things. Like, I'm building this abstract syntax tree sequentially. I just keep adding everything on the end. Like,
Yeah.
that leaves them packed in memory in the right way. And anything where I can't make that work, it just stores an explicit. All of the children pointers are explicit.
The whole reallocating arrays thing.
Well, I don't do that anymore, because it's a 64-bit app. All of the big arrays are virtual alloc to a big size, and if it goes off the end of that size, it'll throw an error. It's actually a little subtler than that, and I don't know if I needed to do this work. It actually virtual allocs a big block of memory and but doesn't big range of address space, and only requests actual memory for it for a smaller chunk, like a megabyte or whatever. And I wrote a page fault handler that goes and virtual allocs more memory. It's exactly what the OS is supposed to be doing.
Yeah.
And so it's probably redundant, but I don't trust it. Like, this lets me choose how much memory to add each, when it faults, when the array needs to expand, I can go and say, no, just add 16 megabytes to the allocation. So it's less overhead potentially.
I'm trying to remember. So I was visiting Jeff at one point, and this was when he had the boat house, right? The house with the boat, and we were going to do something like this. Like I was talking about, like, yeah, I just want to make an array that like auto expands if you're in 64 bits, so you don't have to do all this copying. And we started trying to do this on Windows, and like you had to use huge pages for the operating system to do something somehow, and you only could use huge pages if you like ran as administrator. It was crazy. And I don't know if we just didn't realize something that would have made it work, or what. I'm trying to remember now. I don't know. Did you ever talk to Jeff about this, or?
No, it doesn't ring any bells. But I did bring up on the screen the page fault handlers, and unsurprisingly,
Yeah.
people started asking about it.
So you actually you actually just write until you fault, and then let the handler do the right
Yep.
thing. And so you don't,
Yep.
you could yourself just have a software bounce check, right? And you
Yeah,
just
I
don't
did.
do
I
that.
used to, and I was like, let's try taking it out. And I tested it in the Lexer, and it didn't help performance at all. Because the software
Wow.
bounce check wasn't a big deal, and the reallocating, doubling the memory wasn't a big deal, so it didn't matter to performance at
I,
all.
I
But I'm like,
do I
eh.
do have a speech later on that I'm going to do about why this actually might be a lot worse, but I'll save it for that.
There is an issue of the just-in-time problem, right? That it forces a page fault, like, and that could be some performance overhead, and that's why I grow it by a lot whenever there's a page fault.
I don't want to spoiler what the speech is, but
Okay. Yeah. Oh, you mean an actual talk? Okay.
yeah. It's a talk that I gave that I'm going to do a revised version of. But
I thought you meant you were going to give a speech later in this.
No.
Yeah.
It's just that two things that have the average speed when you profile it, right?
Yeah.
If one has much higher variance,
Yeah.
that actually could be very, very bad, like way worse than people usually think. And so in a case like this, right, if you take a hit every time, then it's like, okay, it's more stable. But it's like if your performance varies a lot because it's faster most of the time, but then it's slower when you take a page fault, right? But then it averages out, like you can't tell the difference in the profile. That still might be worse.
Yeah. Well, but the realloc is also inconsistent, so who knows?
Yeah. I'm not saying that one or the other is right.
No, I realize, but that is definitely a potential issue. Anyway,
I'm gonna have to ask Jeff what the problem was now because I totally don't remember anymore.
Anyway, so this is just one of the crazier things that I did, and it was really partly just to get rid of the bounce check, but mainly it was because if you realloc, the stuff actually moves where it is in memory, and if you have any outstanding pointers, they break, just like the garbage collector thing we were talking about before.
Yes.
So I was talking about this with Fabian, and I wasn't even really thinking about that part. And I mentioned to him that it's kind of annoying because not only does the allocation range check, but I keep having to make sure I write the code to make sure it's reloading the pointers correctly. And he's like, yeah, that's probably the better, not worrying about the performance, but that issue is, you probably don't ever want to move those big arrays.
Yeah. Totally.
So anyway, but the main point that I was talking about was just that the AST does in fact do this thing of save 32 bits by not storing one of the pointers and relying on it being the next address in memory.
Yeah, someone's asking in chat, what's the issue with just reserving and committing? The point is, well, I mean the point for my kind of application, I don't know in your case, but like you don't know how big the arrays are going to be in the end. And they might be different lengths, maybe. I don't know. And if you spend a lot of memory on some that are going to be short, but you make them long, then you're not using your memory, right? Very well.
The answer to his question is the thing I said already. This is what the OS is supposed to be doing. Like,
yeah, that's true.
Like I virtual alloc say 2 gigabytes for every array. Like, and maybe there's like maybe that's not exactly the size. I don't know. It's limited to 4 gigabytes. Like. Well, the array indexing actually can go bigger. So I might have command line switches so you can override that and get more memory. But let's face it, if you're compiling something incrementally and it's that big, like considering that all the structs are trying to be small, you would have to have a really big app to do that. Oh God, what a stupid sidebar. I've already forgotten what I was talking about. What was the question?
I don't know, man.
God. Oh well, this is so bad. That's like the third time I've done this talk.
It's okay. It's Saturday. Everybody's tired from working hard all week.
It's just talking about that's what Windows is supposed to be doing. So yeah, yes. Maybe it is doing the right thing, but this probably is not any worse than what it's doing. So I'm more comfortable doing it this way, knowing exactly what's happening, that it really isn't trying to do it. And partly is like we may port this to the Mac or something, and I don't know if will the Mac do that right too. Yeah, I don't know. So hopefully it'll just be a cross compiler and it will only ever live on Windows. But I just trust myself. I just know for sure that the memory isn't committed. It could lead to a sort of a double thing where it's like, well, now I actually allocate the physical memory, but the OS still doesn't allocate the physical memory until I use it like yeah, maybe that like adds some extra overhead. But because I do it in such large chunks at a time, I don't think that overhead is significant.
So when you lay stuff out in arrays, are you just doing like you're not even really doing SOA so much as it looks like small structs of things that are all highly relevant to each other in the same space, right?
Almost all of it is not SOA because of the tree problem. Because
Yeah.
um, so now there's one thing, which is that because I'm doing this, you could imagine the pointer thing. What you do is you make one 4 GB array, and everything uses indices into the same array. And then you don't have the problem I was saying of using up a bunch of registers on all the pointers to all the arrays. And you just use byte offsets as the byte indices to get the offsets. And that would totally work. But I'm also trying to do a bunch of stuff where I want to allocate things continuously to make sure the prefetching works.
Yeah.
And so as a result, I do end up with a bunch of arrays. And then there are some arrays that are directly indexed. So if you want, we can actually talk about my Luxor, which actually does data-oriented design in an interesting way, I
Sure.
think.
We could do
But
that.
but before we do that, I wanted to go back to that list of its base types. So there's actually four separate trees, 4 separate arrays that store abstract syntax tree nodes. So the statement nodes, expression nodes, declaration nodes, and initialization nodes. And that's literally just so all of them can allocate sequentially and get the implicit pointer. Because if you I'm in the middle of doing an expression, but now I need to do some initialization, well, then I'll have to allocate those initialization things. And if they allocate from the same array, then the next thing in memory isn't going to be the child of that expression, or that's not the best example, but there's that kind of issue that turns out to come up. And so I kept adding more and more of these, and I ended up with 4 of them, which is terrible in terms of the registry. It's the opposite of the just have one thing and have all the pointers be from it. And it's, again, possible that, well, you don't need them to always follow after each other. You could, I don't know. Well, first of all, I could just get rid of that. That 32-bit, I could not save the 32 bits. I could always have everything be explicit and rely on things mostly being sequential, and the prefetching addresses all the issues. And sometimes things get spread out, and it's not a big deal when they're only occasional. I don't know. It's right, because I'm doing this data-free optimization before I tested it. So,
Yeah.
but so you can see that some of these, the info array, the identifier array. Okay, identifier array and others. That means that there is a structure of arrays there. So there's multiple arrays indexed by the identifier. I think that's mainly just because there's the actual what's the identifier bound to once you type check, I think is not stored in line. I do actually do the thing though that you were talking about of is it in base? I don't even remember where is. Okay, it's not in base. Oh, because I'm not looking at expressions. So yeah, all the expressions. Wait, how does this work? I haven't thought about this in forever. Oh, these are all. None of these are expressions. That's why. Yeah, so all the expressions have this t-index type, and that's the type checker fills that out. So I definitely do the same thing that you do of late adding stuff to the structure. Like the initialized structure, the type is empty, and then it gets added later.
So T means type checker in this case.
T is type.
Yeah.
T index. So the whole thing of that is just that all of those things would get so wordy. All these, because these are just substitutions for pointers, right?
Totally.
This is actually a type info type or something like that.
Yeah.
And if I had to spell that out, I
get you. I would probably do that in this case too.
Because there's, you have to. It's an expert code base, right? You have to learn these couple rules, and then the code base makes sense.
Yeah. Well, and also these are things that you wouldn't want to not know before you went to program, right?
Yeah, exactly. You've got to know how the whole arrays indexing stuff works. Yeah.
Yeah.
But anyway, there's a lot of actual complexity to this problem of leaving the having the next AST node be immediately following in memory because of the weirdness of how expression parsing works, that you sometimes have to parse the child before you know what the parent is, because you
Yes.
um and so this does some very gross stuff to do that, and I think we won't talk about it. But it's a yet another landmine that you definitely, when you come into the code base, you will like almost certainly get screwed up by it if you don't read the right part of the documentation. All right. Anyway, shall we talk about the data-oriented design thing for the Lexer?
Sure.
Okay. So I'm not sure what the simplest. The preprocessor has a whole bunch of these scanning loops, and I'm not sure if maybe it has a clearer one. So the basic model in Alexa and then the preprocessor is that you just scan a pointer through from beginning to end, and you do stuff at different times, but you just go through. I rely on a trailing null. So any file that has a null embedded in it, it's just going to terminate when it hits that. I mean, I could check whether it got to the end. And I think I haven't implemented it yet, but the intention is that you memory map files, except if they're an exact multiple of the page size, in which case they won't end with a null. But because what the memory mapping does is it puts zeros in memory.
Yeah. So you just don't want to have an extra page just to put the 0 in?
No. So it'll allocate the extra page. Well, see, yes, you'll just allocate an extra page if if the file size is exactly the page multiple of pages, then you allocate an extra page to have the 0.
Right. I mean, that seems like the default thing. Oh, you mean like
always,
if you?
Oh, you're saying just always allocate an extra page? Yeah.
I'm trying to think of what you were, because like I was sort of thinking, isn't that the default thing that would happen? But I guess if you use like mmap, I don't ever use like actual mmap API calls, so
yeah. Well, it's a different API on Windows.
yeah.
But anyway, so a typical simple scanning loop is something like this. It's efficient because like as long as this is an efficient evaluation, you're just testing and going. As soon as you want to start doing something more complicated, you tend to use a state machine. So is there a simple state machine? That's a complicated state machine. That's so this is an example of a kind of a typical state machine loop. And there's one in the Lexer, but I want to use this as an example just to do it. So you're going through so this particular thing is trying to scan from the next directive, and it doesn't need to do anything with the text until it finds the directive. So just advances the pointer, remaps it to shrink the table, uses a transition table, and it has to keep track of the line number as it goes, so that it can output the pound line equivalent stuff, so that the compiler has correct line numbers. So this is what like an efficient way of scanning text looks like if you're not doing SIMD crazy stuff.
So the transition table is what? That's just a way to say like.
So it's a finite state machine, and you're just switching between the states of the finite state machine based on the input characters.
So like an NDIF, for example.
So this is you're scanning. This is scanning for pound, basically.
Yeah. Oh, okay.
So it's doing is it's like keeping track of, am I in a comment or not in a comment?
Okay.
Because if you use a multi-line comment, that disables the pounds inside of it. So it's keeping track of is it in a comment or not, and it's keeping track of whether you're in the white space at the beginning of a line, I guess, because you need to know when you hit a pound if it said that you don't want to process, you need to know that that's an error. So
that's a pretty small table, probably.
Yeah, well, so the biggest thing is that you have to remap to you have 256 possible inputs.
Yeah.
And so to keep it small, you do that. But I don't remember how big this particular one is, and I might be reusing the same classes that aren't that small. But yeah, okay. So I think this is Oh no, that's the exit states. That's for a more complicated scanner. So yeah, don't. I think that's for a different scanner.
And
But
so I assume you reuse that logic in all the different scanners, right?
so a
Because
lot of this, so the simplest scanners, the fastest scanners are actually the earlier ones that don't have to even do that kind of logic that I was showing, where they're just a simple while loop. And then I have like 4 or 5 different scanners here that use the same kind of logic. Yeah. They're doing more complicated stuff. The default behavior uh, in the normal code is that you are copying out the input because you're passing it through to the compiler.
so
So
it is quite possible that what I'm about to say is not at all true, but like
sure.
it's my naive impression that if I was going to do that, that just writing out the branches would probably be faster in the sense that the CPU can tell what's going on a little bit better and like speculate that a little bit better, right?
No, in my experience, go ahead.
But
If you have
maybe
more to
not
say.
because if it's a small table and it's all in cache anyway, then
That's
maybe
exactly
that
it.
doesn't matter.
You actually do this if this code is this like so a tight loop is always the best thing as long as you don't fail the memory thing because that's a branch misprediction problem. So if you try to track these states, uh, there's also potential combinatorial explosion because you're like, am I in a comment or not, and keeping track of some other bit of state. But you can just do it with a bunch of straight lines. In all my experience testing this stuff, no, it's always faster to use the state machine. I mean, eventually the state machine blows up probably in size and it becomes not efficient. All right. So the Lexer, because I did performance tests, this has a bunch of if defs to do things different ways. But so the classic Lexer that we learned is a thing that the parser calls every time it eats a token, and the Lexer returns the next token.
Sure.
And I have a version of Lexer that I published in a paper 10-ish years ago, where I Lex about 1,000 tokens at a time. I keep a buffer of tokens, and the Lexer just runs over like, hey, 1,000 things, and then the parser calls and consumes from that buffer. It's not multi-process or fiber thing. It's just, oh, if the buffer is empty, call back into the Lexer to generate more. Because this is the data-oriented, an aspect of data-oriented design. You don't actually want to like keep switching between those two things because the branch predictor there's a global branch predictor that's looking at the whole recent branch history, and there's hot code paths and stuff like that. And so if you're constantly alternating between the Lexer and the parser, there's a potential performance in there. So I wanted to try writing it this way we've thought about. But now we're at the point where, hey, you can just load the whole source file into memory, right? You don't do any buffering or anything. Yeah. And it's like, I'm just going to Lex the entire file. That's the model that this is doing. It just Lexes the entire file.
I've thought about doing that. Does that help in terms of simplicity substantially? Or because the thing about getting the next token is like, yeah, it might do something a little more complicated, but that's very black boxed away, you know.
By design in the language, it should be able to be done as a separate process, except for the type def problem. In my thing, the type def stuff is solved in when the parser consumes from the Lex buffer, it does that extra bit of work of resolving the type def problem.
Yeah.
So the Lexer just produces identifiers and doesn't care.
Yeah, that's what I would do too.
So I haven't tried it the other way, right? I don't have. This is one of the things. It's a lot of these things. I tried to do it the way I think is fast, and I never did it the way I think is slow. So I don't have performance numbers for the quality of that. But it does. You didn't ask about performance. You asked about does it? I don't remember, simplify things or whatever. It enables something that I don't think I would try if I were only producing a buffer of 100 items, let's say, which is the following interesting thing. So here's the more complicated state machine loop. We're not going to talk about it. I just wanted to show you the simpler one so you could see that's the same pattern. And here you can see the old code where it would resize the array if it needed to. So once it's found a token, so this code may only run over one character, because if it's a plus, well, I guess that goes 2 characters, but the well, actually, let me rewind for a second and talk about this a little bit because it addresses your thing. So one of the things this state machine does is it skips leading white space before the token, and it parses comments and skips them. And it sets a variable to tell where the start of the token was, but it parses the full token. Because one of the things you can do is you can say, oh, when I hit the first character of the token, I stop, and then some following code resolves what token it is. And the thing about all that is that you just always get branch mispredicts because you like have to switch on the first character of the token or something like that.
Yeah.
So this thing actually, and when you switch between white space, like if you do a normal loop that you were kind of talking about, if you do a loop that if I hit a comment, scan the comment and do that, you're just going to get a branch mispredict every time you hit a different switch modes between the different loops, right? Like because it's always going to be somewhat random. Like your source code is not like sometimes you cut and paste lines and have a bunch of lines that look similar, and maybe somehow that would somehow be able to be detected by the branch predictor. But most of the time you have this really freeform stuff, right? Like this loop itself is just not very much consistency, even though it's got, this one assigns and this one assigns, but this one has 2 array subscripts and this one has 1. Right. So it's just like trying to imagine what the branch predictor does. I mean, I don't know exactly. And I didn't keep any code around doing that comparison, so I can't show it to you. But in fact, I can't show you anything because I don't have this compiling in 64-bit on my home machine yet. But because I haven't been doing performance stuff for a while. Anyway, so the point is that like this is doing a bunch of stuff, and the goal here. Remember, I said at the beginning that my model is memory, keep things small and pack them sequentially, and then avoid branch mispredictions. So every time you hit a comment, you would get 1 or 2 branch mispredicts, probably one when you detect it and one when you exit from the loop scanning it. And every time you have to scan white space, you probably get a branch mispredictor too. And so this just does away with all those branch mispredicts, and in theory, you only branch mispredict at the end. You pay the cost of a bunch of extra logic on every character. In my tests, it was better.
Yeah, well, also,
I don't remember numbers.
And again, how much that matters is unclear because, even though you're doing a generally single-threaded model for this compiler, right? One very easy way to multi-thread it is if you're going to load the entire file and convert it to tokens anyway, you could just do that in a thread, right? And then,
sure.
pass those back.
But I don't want to do any threads because like I said, I want the make system to be able to use threads and not
be surprised by the cores being occupied.
By one compiler, yeah, exactly. Right. Like we don't have a good solution to that problem. It would be ideal. That case I was talking about where it's like I'd really like to have 2 threads on the same core and the one thread like is doing the look ahead for it. I can't communicate that to a build system. That's the problem. Right?
Well, that's one reason why I don't like these things. I mean,
sure.
Well, in principle, if you didn't care about that, of course, you can just crank through all the tokens on a thread, and it's like almost the best kind of multi-threading, right? Because you literally don't.
Yeah.
It's very clean.
Anyway, this code is very messy because I do it 2 different ways because I have a branchless version and a branching version, and the branching version was for this stuff faster. The branchless version basically writes to 2 different array indices, and one of them it doesn't update, and one it does update, and the branching one just writes to the one that actually needs to get updated. But anyway, so what this stuff is doing is it's recording that I saw a token of a particular type and what its start and end was, because that's what this loop up here did. And as soon as it's recorded that, it just loops back up and scans the next token. So it hasn't even done anything with the token; it just found it.
Sure.
However, there is this fallback case where we parse floating point numbers and strings in C code instead of trying to have the state machine parse them. Except I do actually now have the ability to put it in the finite state machine. And if I put those into the finite state machine, the whole thing was 1% slower because it made the start state machine bigger, and it's just not like you're already paying once you've exited the token. And you have this complex thing to parse. So anyway, we're getting to the actual interesting part. What happens once I've gone through the entire file, and for the most part, all I've done is keep track of where the tokens are. I now go through them non-sequentially, so there's some cache missing happening here. Down here. Here we go. Nope. Okay, here we go. First, it allocates a whole bunch of stuff. What it does is it now goes through every single type of token. So this is the data-oriented design part. It goes through every single type of token, and it has built a list for every single type of token of that data of where that token was. And it goes through every type of token independently and computes the actual token information that's going to provide to the parser. So if it's a single character token, like it's a minus or a plus, it actually just uses the value itself for the thing, that classic strategy that I know you also use in your thing. If it's a 2-character token, there's a little perfect hash table that it can use to map it. If it's a decimal literal, it's got code here to compute the decimal literal. It's got a bunch of special cases to try to do it faster than calling A to I. If things are within certain ranges, it can use simple logic. And the very last one is the identifier, I think.
So if you, for example, you're going through your code and you find a floating point number, right?
Yep.
Then that's actually a 2-pass operation. The first pass to find the range, and the second pass to actually do something with those characters.
Exactly. But it's
Is that a good idea? I mean, I'm not sure I love that.
Right. Well, so it's a data-oriented design because now all of these loops are tight loops that don't deal with, right? It's not switching between all these different cases. Some of these are very complicated, but they all take no time. All the time is spent in, testing my code, which doesn't have lots of long identifiers. But I think the test code I had also didn't have any floats in it, or not a lot of float literals. I mean, here you're parsing a character literal, and now the code to parse that, this character constant function call, is just doing the same thing every time through this loop. It's the thing that is fast. Okay, so this is based partly, it is the data-oriented design idea, right? It's homogeneous. It's an array of homogeneous things. It is indirect, so it does have to go locate it in memory, and that's part of where it's it would be nice to have the smart prefetcher, right? The programmable prefetcher. And because this is an array, I could actually just do it. I could just have a prefetch here of, look 8 ahead and prefetch, or whatever.
So I guess
things are arrays.
So assuming that this doesn't cost too much because of that, right? Because everything is local. The question is just for me. So the first pass, which uses a strategy you have of the state machine most of the time, probably not all the time, right?
But to an approximation, you could say all the time.
So of course the reason it's doing that is to be simpler than what the classical lexer would do in that situation, right? Because a classical lexer would just do all the work in that same loop.
The reason it's doing it is to do this. The goal here is to have these data-oriented design loops, right?
But I guess what I'm saying is how much faster is that state machine thing than just having done the work back then,
Well, it avoids the mispredicted branches that. So the whole reason that all of this is being done is to avoid mispredicted branches. How much difference does it make? I don't know, because I never tried implementing it the slow way. Well, the quote unquote slow way.
Well, okay. So there's two, let me understand better.
Sure.
Which mispredicted branches, right?
Oh,
so I can imagine two kinds, right? Yep. One kind is just because if you, let's go back to the floating point number example, right? As soon as you start adding the code to interpret the floating point number, there's just more code there, right?
Yep.
And so you're giving more load to the branch predictor and whatnot, right? So I did a float and that put a bunch of stuff in, and then you went and did a string and then you did it whatever else, right? So it doesn't stay. So there's that. The other one is just maybe like you were saying before, there are fewer, the state machine is just more efficient than a set of static branches for that kind of job. And that increased efficiency doesn't necessarily lend itself to interpreting the now let's ignore the fact that I think the floating point number was one of the cases where you said you weren't really doing this, right?
Yeah, the
But
floating point number is one of the hardest ones. But like the real win here is from the ones that are relatively easy to parse, and also the identifiers. But
well,
we
I
can,
mean, the thing that I'm worried about is for things that are super easy to parse, like 2-character tokens or something, right?
Mhm.
Then the overhead of visiting it twice might also be high, just because visiting it once is not that slow. You know what I mean?
Okay, well, so here's the thing. Like literally, the design is let me remove every mispredicted branch that I can.
Sure.
Okay.
Okay.
Um,
Yeah.
Now it comes at a cost that the second scan has to access the memory, and that may not be in cache. And because we do the token types independently, the um, they could be scattered all over the memory. Like for a particular type, every instance of it might be in a different cache line, and so maybe that's going to perform very badly. That's the thing I'm giving up. But so here's the C-Lexer library that I have that's sort of a classical thing. And so what it does is, okay, it skips white space. And my rule of thumb on this is it's going to mispredict once. And then it tries to parse a comment. It's probably not going to, it's only going to mispredict when it hits a comment. Right. So
Sure.
then it tries the other kind of comment, and you could combine these and avoid the branch misprediction. Then it does a switch on which character the token starts with so that it can handle all the different cases of tokens. And that switch always mispredicts because it's a switch, so it goes to a different statement every time.
Sure.
And maybe it, there's a classic strategy where you use, you dispatch in interpreters where you dispatch your switch after every different type, so that if there's a correlation between two adjacent instructions,
yeah, I don't know, man.
the second one, and so maybe you could try to do something like that here, but I don't know how. So to avoid the branch misprediction on every token right here, that is the whole reason for that other design. This branch mispredicts on every token. And so literally to avoid that, you do this other loop thing, and now you branch mispredict at the end of the loop, right? Because the count was unpredictable, and so you'll...
Okay.
So to a first approximation, that's what that's...
Okay, so you're avoiding mispredictions here. Your post process is fast because it's all packed together, and both in terms of instructions and in terms of data, right?
Except that it's accessing the source text semi-randomly.
Well, but there's a second thing too, which is
Okay, go ahead.
The parser is going to use these tokens, right?
Yes.
And typically
it's repacking. By the way, the output of this is repacked back sequentially.
Oh, okay. Never mind. So that gets rid of the parser problem that I was going to mention, because you would be jumping around in things that are ordered by type, right?
Exactly. So what it stores is way back up here in this really gross, hard to follow code.
Yeah.
Because it's the two versions. All right, we want the branching version. So it stores. Okay, so there's a bunch of arrays depending on the type of the token. So it gets the one for it. It stores where the end is, it stores where the beginning is, and it stores the number of tokens, which is going to be the token index that's going to output to. So it avoids that problem. It's the opposite of what you want. What you actually want is to sequential read and scatter your writes. Oh, actually, this does scatter writes. Yeah, right. So this, because it writes it back into the correct order, it's actually scattering on the right here. Because these are the outputs are non-sequential because they're scattered sparse tokens. The actual performance, when I measured it, if I recall correctly, was that all the time was in either 1 char token or 2 char token, but it was of this section, 20% of the time was in 1 char or 2 char, and the identifier was 80% or whatever. And the identifier is just doing a hash table lookup.
Yeah.
And I actually use STBDS, which isn't very efficient. So because the STBDS's goal is to be easy to use, and it's not. and so it's just off by an order, not an order of magnitude, but probably could be 2x faster or
So
something.
what? So when I was doing hash table stuff, I was never a big hash table guy. So I used the one. Maybe it was in Promised or something. I don't even know if Promised had a hash table, but there was some code of yours that had a simple hash table, but it wasn't the official STB header file, and it was just very straightforward. You know, I don't even remember the official terms, but the one where you don't use a linked list of anything, right? You just store the things in the array and whatever, and there wasn't even like quadratic probing. Do you do any of that in the STB header file, or is it?
STBDS, I think, does quadratic.
Okay.
But I do intend to just replace this with a local implementation. Oh, I should mention, for people who are asking, I'm seeing RAD code. By the way, none of this is actually like the normal RAD header files and stuff. This project has been built from scratch.
Yeah.
So you're seeing secret RAD code that's the compiler code, but it's not like RAD code used for anything else.
Yeah.
Anyway, so this is, in part, like, it's just a pattern that we've seen at RAD that's efficient, is to use more loops over something that do simpler stuff. Because, for example, things can stay in registers, like not necessarily in this particular instance, but when you make smaller loops, like, you get things like, everything can live in registers. Whereas when your interior of your loop is very branching and handling lots of cases, you don't get to hoist stuff out of the loop and stuff like that.
Yeah. Yeah.
Whether that applies in this particular case, I don't know. And like I said, I never wrote the other version. However, I have performance tested old compilers. Like I said, I did a version of this finite state machine, but not these split loops. Like I wrote a paper, and I had a version of the Lexer, and I did test that one against this one, and this one was faster. But it was not 100% apples to apples comparison. So. Anyway, that's like the most interesting optimization thing in here, and it is literally the sort of data-oriented design model of taking some heterogeneous data, and we actually shatter it out into homogeneous loop arrays so that we can use homogeneous loops. Which I just think it's interesting, but it's also basically the only place you can do it, because after that, everything turns into a tree. And
Yeah.
people are asking, like, how much faster is it and stuff, and I should mention, like, so I wrote the Lexer in December, so I don't even remember. Like, it's probably written down in an email somewhere, but I don't remember what the performance numbers were.
So you measured it at one point and you felt fine with it.
Yeah.
Yeah. Yeah, I don't know. The tree thing, I want to figure something out for that, man. I don't know what it is. I feel like there's just going to be something that could be done there that nobody's been thinking about, because nobody's really been very data oriented.
Well, so my model is that mispredicted branches are bad, and the tree traversal, even though I pack everything sequentially, so it's all sequentially in memory, every time I traverse the abstract syntax tree, I'm going to pay the cost of switching on the node type at every level. Yeah. And that's going to be a mispredicted branch most of the time. And I don't really see a good way to do that. The strategy here, the finite state machine, for dealing with sort of heterogeneous comments and white space and all that stuff, is valid. If you could find a way to traverse your abstract syntax tree with a state machine, you probably could, in theory, get some savings. However, the reality is, at every step, you need to do something. Yeah. And so that do something is going to require that switch to the right thing to do. And I don't think you can do this strategy of this splitting them out into heterogeneous stuff, because you're doing like type checking. You're propagating your types up the tree. You got to do it in order. Like, I think Mike Acton did a data-oriented design thing where he talked about doing tree transforms, propagating transforms of a tree. Okay. Where you do it by, do all the lowest, do it if you propagate them, you propagate them downward. So you visit all of the nodes at the highest level. Then you visit all the nodes at the next level down, and then you visit all the nodes at the next level down. And if you can keep them in arrays that way, you could actually be efficient. But
Yeah.
how you get to that from a tree yeah, I don't know. So in my design, I build the abstract syntax tree. I'm gonna walk it once to do the type checking, and then I'm gonna walk it one more time to do the intermediate code generation. So
Yeah.
I could make it single. I could try to make it single pass and avoid that, but the complexity of that isn't worth it.
I can almost think of some weird stuff for my case. So again, my case is really different from yours, right? Due to the nonlinear compilation. And
Yes, absolutely.
so my big issue is like sometimes I don't know when something's going to be ready. And
Yep.
the way that works right now is, okay, so, I do this flattening thing that I talked about an hour ago or whatever, hour and a half to be reentrant and whatever. But basically it is just a tree traversal. It's just flattened into an array. And, I go look in someone else's tree somewhere else to see if this identifier now has its type ready or whatever, so that then I can use it, right? And sometimes the way that I use it is complicated, and sometimes it's simple, depending on whatever expression is using that identifier. And I could almost imagine reversing that causality, so that like somehow when the identifier was ready, I mean, identifier is just one type of expression, right? But it is a specific case that a lot of people block on, and like I could almost imagine turning it around, and like when it's ready, it happens to know an array of places where it's going to poke its type instead of having a bunch of people pull the type. But like, it's not really clear to me that I'm really going to buy something with that. Yeah, it's interesting though. Like I feel like, I mean, we've been doing trees for compilers since like 1950, right? And there's just got to be another way to look at it that's just as good. There almost can't not be.
I think it's, to me it doesn't. I disagree. Like, I mean, to me it just feels like computers just aren't good at certain kinds of things, and heterogeneous trees are one of the things they're not good at.
Yeah, but maybe that's the thing. Like maybe the problem is the core conceptualization of whatever's happening, and like maybe I just think of code as a syntax tree because that's what I was taught. Right?
Oh, okay, yeah.
And,
I guess the reason I disagree in that sense is like, yeah, okay, I guess you're right. I mean,
I just don't know what's better, right?
Things
like,
do have a tree-oriented dependency, but yeah, maybe you can flatten it. I mean, so does an intermediate representation, and it is normal to flatten those. So yeah, I don't know. So somebody asked a question, by the way, I want to answer. Not in this case. I'm not sure what that part means. Structure-wise, you could, talking about this Luxor thing, you could parallelize all of the Luxors for the different types, right? Once you've had the pre-process. Yes. So all of these could be separate jobs. There's really no reason to do it that way, because in reality, all of them take 0 time except 2 of them. But
so the second pass, you mean, right?
Yeah, the second pass that then does 20 different cases. Those 20 cases could all be jobs. But yeah, so and so if you had similar scenarios, you could imagine if you had other scenarios where you tried to do this thing, where you have a heterogeneous array that you shatter into multiple homogeneous arrays, and then you rebuild the output from it, you absolutely could split those and get some win from it. But that first pass doesn't get split up, so whatever. Casey asked, what is the penalty you were worried about on the branch misprediction? Well, the branch misprediction. I mean, you lose all your speculative execution, right? So, which is huge, I think. I don't know. It was faster too. So, like I said, that's just my model. My model is avoid branch misprediction. I don't have a quantified model. My model is avoid branch mispredictions, keep things as small as I can figure out how to make them, and allocate or not allocate sequentially, but allocate in a pattern that lets you visit sequentially.
Dude, I would love to be able to use VTune to verify my mental model, but like we were saying earlier, it's just not easy. It's just
well, there's also that thing that's a very vague mental model. And there's that thing that I said on Twitter, which is that Fabian believes that you can have reasonable mental models for how
Yeah.
modern processors work.
Yeah.
And the problem is he didn't give any useful information about how to do that. My comment about that was because I had sat with him at lunch, and he made that argument in over a half an hour or something, right? He went into some details about it. So I don't know if I can coax those details out of him or what, so that other people have some chance. Because I understood what he was saying at the time, but I didn't really retain it. So he didn't add any real value to the world that way.
So Casey says, so it's the 20 cycle hit on the front end that we are trying to work around here. My impression is it's what you're talking about is much bigger than that.
Yeah,
I might have the wrong mental model too. But...
It's the 500 micro ops that have been speculatively executed that in the 20, or I don't know, the 500 is the right number. Sorry, if it's only 20 cycle, I don't know. It's 20 cycle that's the right number. So it's 100 micro ops. The whole point is that the reorder buffers or whatever these days are huge because they do speculatively execute that far in front. So I don't know that the 20 cycle doesn't flush the whole window. It just flushes the dependent instruction. It flushes everything that happened after the branch mispredict, right? Yeah, it has to. There's other things where it speculatively executes based on what it thinks the hash, the memory load might be. I don't know if that only flushes dependent instructions or if that flushes everything. But yeah, hundreds of instructions into the future. I don't know. It doesn't speculatively execute that far ahead unless it is waiting around. But if it's a branch, no, it's everything in the pipeline is speculatively executed. That's, I don't know how to explain this. This is my mental model.
Maybe we should get Casey on Discord.
Well, here's the thing. It's the mental model I've gained from talking to Fabian, right? So I can't argue it.
Yeah, that's true.
I haven't retained the details. I just formed this mental model. So I have no facility to explain to Casey why I believe this.
We can bring Casey back.
But on the other hand, all I can say is, hey, it really was faster. So I think it is the correct. I think it's a reasonable mental model. I'll put it that way.
Okay.
I don't know what the actual cost is, but it makes sense to me. There's clearly a trade-off in this particular kind of scenario of the potential that the memory accesses are going to be inefficient. The scattered memory accesses are going to be inefficient. This is not a solution that's going to work all the time. One of the things that happens is it's the position in the source text, and the source text is the file that I loaded from memory. So if you use tabs, there will be fewer characters, and tokens are more likely to be in the same cache line.
That's a great new entry in the tab versus space.
Yeah, exactly. And I use spaces, so and it was tested on spaces, so who knows?
Every reasonable programmer uses spaces. Come on, man.
But I don't know. 64 characters. How long is 64 characters? A lot of this stuff is in this.
Yeah.
If you had two integer literals in this expression, they would both be in the same cache line a lot of the time, and so you would still get some cache coherence, but not as much. And it's I could definitely just stick prefetches in here. It's just everything was zero. It was spending zero time in most of these loops, and the ones that it wasn't spending zero time in don't actually do this thing because sneaky thing, right? The identifier does have to access the memory, but it's hashing, so that's going to be the bigger cost a lot of the time. But the 1 character token and the 2 character token actually write out actual characters when it's building so when I build the tokens, I build these token lists without knowing what type they are. They all write the same thing, and all of them write out the first character and the last character of the token. I think it's first and last. And so then it doesn't actually have to go back to the source code for the single character tokens. Actually, the 3 character tokens as well. Those only actually need the first character. It in the structure that it wrote out for these things, it has 2 bytes, the first character and the last character. So these 3 loops right here don't ever actually access the source code again. because they have enough information to reconstruct it. It does mean it's paying the cost of writing out those two characters into every other array that didn't need them.
Mm-hmm.
Because that's the whole point. It just always does the same thing for every token.
Yeah.
But because most of the time is spent in one of these three or in the identifier, it's not a big deal. Like literally, it was. You can see I put these profile markers around every single loop, and they were just all basically 0 time. I mean, it reflects my source code. Other people's source code maybe will have a lot more strings and a lot more, whatevers, and spend more time in some of these other things. So
yeah, I mean, this is for like one file, right? Or one C file.
yeah, I think this was stv.h actually. So it was 20,000 lines of code or 15,000 lines of code, and I ran it 100 times or whatever to get useful, or to get strictly good numbers.
Yeah.
And this is actually an interesting example. If you see a 0, when you're lexing, when you see a 0, you have to do different things. Like if the next character is X, you do one thing. And if you do, if the next character is a number, then it's an octal one, right? 0 has to be treated specially.
Dude, I hate that.
Because the state machine already had to treat 0 specially, I added a case where there was just a literal 0 in your code. And then it gets a really super fast path. So anytime if you use a null pointer, like you initialize it by assigning it 0, or null, which the preprocessor turns into 0, that will take this extra fast path that doesn't do anything at all because it just knows it's a literal 0. And I was just like, I might as well put it in. The state machine already knew it. So I just add one state to the state machine and have the super fast loop. I don't know how much difference it makes. I never tested it without it. Right? It's just might as well. 0s are really common in C code. So
that's true.
Anyway, that's way too much on that topic, but well, maybe not, because that was the whole point of talking about this, is to share with everyone, not to share with you.
Yeah.
So, yeah.
I mean, do we have questions from the audience about what Sean's talking about here? Address them directly to me or to Sean, maybe, because otherwise, because there's some people having chat already back and forth and asking questions from each other. Sometimes it's not clear who you're asking, and so forth. Let me close my window here as well. I'm getting cold. So I also have to say to both Sean and chat, my brain is not running at 100% today, so I probably do not have as vibrant in the way of questions or other investigations as I normally would have. Just I got up on the wrong side of the bed today, and I'm only at 70%. So
are there things that you're doing in your compiler, thinking about speed, that we can talk about, and I can quiz you on them, and then you don't have to figure out you just have to figure out how to answer the questions?
Well, for me, it's different again because my long-term plan for speed. Well, there's sort of two sides to it, right? The long-term plan is actually use the cores in the computer, right? At the level of the application and not the level of the make system, because there isn't a make system. And so that is hard for certain parts of the compiler. And it's not that easy even for the other parts. I definitely have, I have a spurious bug right now where one out of 120 times it'll fail to compile correctly, except on the build machine where it's one half the time or something ridiculous. So that's the kind of trouble that threading gets you into. So that's one category, and that's what I'm viewing as being the most important, because if I'm going to get to a million lines per second with this involved of a programming language, it's not going to happen without that, right? But then secondly is more like what we were talking about in the beginning, just making sure I don't dig a deep hole for myself that I have to climb out of later, right? And so I'm not going as far as you are in terms of data structure design or worrying about branch mispredictions and stuff. The number of branch mispredictions that I worry about is approximately 0, unless there are occasional routines that are at least kind of linear and where I obviously could do something. So for example, if I'm converting, so my intermediate representation, which is, it's like a sort of bytecode instruction-y thing, but they're all the same size, which actually is maybe not good. Like it was simple to think about, but like some instructions use more memory than they need to. But the loop that converts that to x64 could be quite a long loop for many procedures, right? Because who knows how many like intermediate instructions that you're going to have. Some functions are going to be short, but even like some people would be surprised, even a function that you think is short could have, if your programming language is high level, it could have quite a few instructions, right? Of course, you hope that optimization cuts that down, but like we don't actually do optimization on our intermediate representation yet, right? We feed that to LLVM.
Yeah.
So in the backend that I wrote that just outputs x64, that's one of the few cases where you're like, yeah, I have a really long loop where the things, like there is that branch misprediction problem that's inherent about taking the penalty for each individual instruction, because I don't know what it is, right? But you can at least avoid adding more, right? You can at least avoid digging the hole deeper than it has to be. And so there are cases like that I think about, but a lot of the compiler is just, is in places like type checking. That's where the most complexity is. And it's just thinking about like, how do I deal with this tree? And how do I deal with all the complicated things that need to happen when you call a frickin' procedure, which is like a lot. And, I try to solve those in the naively not slow way, but I don't go out of my way to make those fast yet. And again, the reason, part of the reason is because there's other stuff that just I know is slow. So for example, I mentioned last week with Casey about how there's all these really small compilation units flying around, and we mentioned that briefly today. How do you know what you're ready to make progress on right now? Well, I had an idea way back in the beginning that there would be this like dependency graph, and you have these sort of arrays of like arcs in the dependency graph, and when all of those would get removed from a node, it would be able to progress. That is not the right way to do it for many reasons. The two main reasons are, one, you have this problem where the place where you set up the dependencies is very different from the places that consume the dependencies. And so if there's a mistake, it's very hard to debug and trace back, right? So that was a pain in the ass. But the second one, which is actually maybe more important, is it's not the right model because it's too coarse. Like the nature of dependencies that you end up needing to care about if something is actually ready to compile or whatever is not as simple as, has this entire object been type checked, or has this entire object been, because you often end up in cases where like, well, here I only need a little bit, right? It's sort of analogous to that case where we're talking about in header files about, well, if it's a pointer, you can use it and you don't really need to know the rest of the type yet, right?
To clarify, like, would it be okay to just wait till it's all done, or is it?
No,
there's
because
a circular dependency, so you have to.
Yes, there are cases where you will not semantically be able to compile unless you have a finer grained thing, and they are not uncommon, right? They will just happen with normal code, at least in this language and probably a lot of languages. And so it was like, okay, clearly this is the wrong model, but it was still getting a lot of work done, and I don't know what the right model is for everything. So the dependencies are kind of in there still, but I'm on a long-term plan to draw down the dependencies and remove them wherever possible. But then that's painful because anytime I make a mistake, then the compiler just like fucks up all over the place, and I have a hard debugging about like why, But then I'm replacing that with other mechanisms. So this thing that I mentioned before about how you can cooperatively yield, and often that'll be in conjunction with pushing a subtree. So if I'm deciding that this is an operator overload and I generated a procedure call that is now the thing we want to compile instead of this binary operator plus or whatever. You push a subtree and yield, and then that yielding makes the compiler come back later and do the subtree. And even that is slower than it should be because the mechanism for yielding means I'm going to give up compiling this entire compilation unit for right now and come back to it later. When in reality, it maybe just means you want to fall back to the earlier routine and just recurse on that subtree, but stay within the same unit. So that could be faster at the cost of slightly more complication. But so this idea that you can do that is like a different way of doing something that used to be managed with dependencies in some way. Because like sometimes you used to make, if you were going to add a subtree before, you maybe had to make a separate compilation unit for it because of the way things were stored, and then put that in the dependency graph and set up the dependencies correctly, and that was a giant pain. And whereas now, for this certain class of dependencies, it's like, look, this is a thing I generated, only I care about it, only I am waiting for it. So if I just sort of have this stack of subtrees that have to get processed, that's a very local form of dependencies that is very customized to what I'm doing, right? And so my problem right now is that there's this series of things that are like that, and they're all different, and they all need to be simplified. And because there are a few systems and they're all different, none of them are really optimal. So for example, I still have the old dependency graph thing. And if you've got this dependency graph, what do you want to do? Well, you want to resolve the dependencies in dependency order so that you don't spend a lot of time doing wasted work on the graph. And I do not do that right now. I literally, and this has been true for the entire lifetime of the compiler, right? The way I handle these dependencies is every little compilation unit, which again is often the size of like a statement if it's at top level, or it could be one procedure body or something. Every time I go to that, that thing has an array of dependencies where each dependency is a small struct pointing at the thing you depend on and how do you depend on it, like on what stages do you wait for that thing to go, and maybe a little bit of diagnostic information to help me out. There's probably a lot more than that because my structs are always way too big. But every single time, every single cycle, like it's sort of a frame of the compiler if you think about a game rendering frame by frame. Every single cycle, I just walk in order through all those dependencies and give up as soon as there's one that we can't resolve. But if there's other ones that we could have resolved while we were there, we don't even look. But also things that are in that dependency array that are only for later stages than what we're currently stuck on still stay in the array. Like it's crazy. Like it is slow, and there is no special like graph theory logic being applied whatsoever. It is literally just attempting to do linear passes on these dependencies over and over, and it's still faster than most people's compilers, right? So like, it's a problem I want to solve, right? I want my numbers to go down. I want to make gains in the gym, right? But the complexity is the bigger issue for me so far.
So how do you, I have a whole bunch of things because you said a lot.
Yeah.
I'm not even going to remember them all.
Yeah.
And unfortunately this first one is probably it's potentially going to be huge, and then I'll forget everything.
That's fine.
But, so how do you end up with having discovered multiple dependencies? In other words, you hit the first thing that you don't know how to resolve it, but you keep going.
Okay. So a very common dependency, and again, this is something that has changed over time. It used to be that I would generate a lot of these dependencies in the parser. Let me go back. I'll put my code up here for a second. I bet I still do this a lot. Like, so this.
Let me actually expand a little bit, and because it'll dovetail with what you're saying. Yeah. So I was thinking about what will it take to do this in C, because I said we might want to go this route. Yeah. And my thought of it was that I would make a pass over the tokens and find all the identifiers in the function body and build the dependency list of all this. Yeah. Which is an extra pass, and yeah, you could do it during parse. Although in actuality, you can't do that because you have to. it's not a dependency if there's a local definition for it. So, but maybe in the parse you can resolve that.
Yeah, I think our cases are just really different, right? I mean,
Yeah, that may be.
there's a lot of features in this language that can cause you to depend on things far away.
Oh, sure.
So like
Yeah,
you can import another namespace and like you might have the identifiers already, but they're not inferred, or you might not
Yeah.
even have all the identifiers yet, but we still kind of want to do that because you want to let compilation go forward if you can, right? And in fact, there's a circular problem that you would end up in if you don't do that.
Let me ask a narrower version of my question.
Yeah.
Can you end up with multiple dependencies for a function body?
You mean from the body depending on somebody else?
Yes.
Okay, a function body could have a very long array of dependencies because, for example, okay, we generate one for every identifier, right? That's the case you were talking about. That's not the only time that we do that, but yeah, we definitely do that. We don't do that at parse time anymore, but we do that at type inference time. And again, because I'm not being smart graph theory person, it's super dumb. So if you use an identifier a lot, there's a lot of redundant dependencies to that same identifier that are meaningless, right? There'll be like, so I do some very,
use of it? Okay.
Yeah, I do some very simple things where like, I'll look at the last two elements of the dependency array to see if we already did that literally, right? But beyond
you
that,
you don't want to keep a hash table per dependency list.
I mean,
to resolve it efficiently.
That might be faster, but then once I decided that this wasn't the way things are going to work long term, it's like, well, how much do I invest in that, right?
Yeah.
And then also, I'm just paranoid. Like,
this is one of those things that's really easy and single-threaded because you can just store a flag on the identifier, like a temporary, right? Like you tag the identifier, oh, I've used you for this function body. And when you get to the end of the function body, you clear all the flags.
Yes. Something like that might work. So because we're threaded, we do things a little bit differently again, right? And so like we lex and parse on one thread, right? And then because you don't want contention over things like memory resources, right? The lexer and the parser have their own memory regions, right? And so that identifier like is not shared with other people, but I do actually share it right now among other functions in that same file, right? So if you used X, it would actually be the X for every function there. And that was just because like, I have essentially, like what you would call in a Lisp-like language, I have like an atom table, right? So when I make an identifier in the lexer, I actually look that up in a hash table. And I have a struct that's global to that lexer for that identifier, right? And it used to actually hold some other things. It doesn't really hold that much extra stuff anymore. But you can imagine ways to use that to accelerate things. But the way that you can't really use it right now is exactly the way that you said, because
yeah, of course,
it's not local to that function, but also there's not really a guarantee. Like after you exit the parse unit right now, I don't know what thread right now there's only one thread doing the type checking. So there's that, but like when it gets parallelized, it's not really for sure that it would stay that same unit. Although the more I think about it, the more it makes sense that you would. Cause like as a Maverick guy who's like, oh, I hate the old structure of things. It sucks. I don't want to be like C compiling .o files all the time. My inclination would be to just maximally scramble it, right? And just, these tiny compilation units that I talk about could go to any thread or whatever, because that's the computer sciencey thing to do. But in reality, like if you're talking about minimizing contention and whatever, like the things in one lexical file are going to be closer to each other in terms of referentiality, right? They're going to refer to the same variables more often than they are going to refer to an outer file or whatever. So if you're talking about a scheme where now maybe everything local to my thread I can access quickly, and then I have to take a mutex to get anything far away or whatever, then it makes sense to have that be one file. That's a good unit for that,
So you could potentially have like the Atom table, you could have a copy of it per thread. Oh, I guess you do because you said it's per lexer.
Yeah, it's just that those threads don't correspond to anything after
Yeah,
parse
no,
together,
exactly.
right?
Okay, but so you could imagine that you have the real Atom table, and then you have like a per thread Atom table that has every pseudo atom has a pointer to the real atom. But that and
Yeah.
indirection now gives you the freedom to store per thread data.
Yeah, and there's various things going on with like importing modules and stuff where I've thought about making a local copy of the atom table because yeah, I don't know,
Yeah,
it's just complicated, but I definitely think about that. You probably do. If you don't copy the atom table itself, you may want a parallel array of data the size of the atom table.
yeah, exactly.
You know,
Which, yeah, like if that's one of the nice things about using indices is, hey, you get to have parallel arrays all you want. Which is, because I have the equivalent of an atom table, and they are indices, and they do have multiple. In fact, I can't remember why, but they do have multiple arrays. Okay, let's just continue because I said I had a couple things I wanted to say.
Sure.
I just wanted to mention, early on in that whole thing,
yeah.
you originally said that, like, hey, you don't do anything the number of times you think about avoiding branch mispredictions is like 0. And I just wanted to clarify, I know all that stuff in the Lexer because I can. The Lexer and the preprocessor are the places where this is even possible. So I brought up my type checker here, and there's a giant switch statement, which is not branch mispredict. And then in this case, I do one if, because this particular case, I've pre-computed a bunch of stuff into the table. But here's the current unary operator. You get one switch because it was a unary operator, and another switch because all the unary operators have different things. And then, they do some tests that maybe they branch mispredict randomly. I don't know. I do a bunch of stuff. Like this is effectively another switch here on this tick kind thing. But it's just all random logic because it's the type checking that follows the C specification. So you just have to do lots of random stuff. And maybe, like you said, there's some way of tackling this problem that would allow you to organize this stuff differently. But yeah, it got me. I haven't thought of it. And so, I suck up the branch mispredictions. And in this code, I focus on the memory allocation.
So the thing is, in both the compiler and the game, separately, my bottleneck right now is complexity, right? It's not.
Yeah, exactly.
It's not exactly speed, but I mean, if I could get the complexity further down, I would have more luxury to think about speed again. And in fact, that is my mission statement, because I've said, I want 1 million lines per second, and not by waiting for computers to get faster, by making the actual compiler faster.
Yeah.
So the thing is, if I weren't working on the compiler and the game at the same time, I would have like twice as much brain space, which is actually more than twice as much, right? Because of the way concentration works. But of course, I think there's good reasons to do the game at the same time. So that's why I'm doing it that way.
You have a much harder problem than I do because you're inventing the language at the same time. It's less so now, but to a certain degree. Like, I'm trotting well understood ground, and I'm trying to find faster ways to implement the well understood stuff.
Yeah.
And you're just like, you're trying to invent this whole strategy for the incremental compilation, whatever you call it.
Yes, but I do want to go hammer back on the point just for the audience. Like, I know you know this, but like, that doesn't mean I don't care about speed. The only reason this compiler is not dog crap slow, just like a lot of other compilers, is because I was thinking about speed to a certain degree from the beginning, right? At every level. So it's like when I'm designing the way that type inference works in this language, it's like, well, both for programmer sanity and for compile speed, the semantics of type inference are going to be designed so that they don't get crazy and take a lot of time, right? So that's a design phase of caring about speed. And then just when I'm writing code, because I've worked in video games forever, and video games is one of the fields where people still are reality-based and care about speed. I just know kind of what fast code is like and what slow code is like. And so I know that I'm not writing the fastest code, but I also know I'm not writing slow code, right? Except in some limited cases like the ones I just explained. And even then, it's like I know to watch this dependency thing, and if it ever gets too slow, I at least know some strategies to bring to it, right? But like, there's a big difference between writing a big program like this and minding speed the whole time, at least to a moderate degree, and not doing so, right? If you don't do that, if you don't think about speed, you'll get something that's way slower, and then you'll just make too big of a job, right? At least with this program, the things that I would do to make it faster are not stupid things. They're structural things, like, oh, maybe I want to separate all the syntax tree nodes into two kinds of things and store them separately, right? Or maybe I want to have a parallel array to what's in this atom table and store stuff there. Like, those are all things that are like, I almost don't know what to say. Okay. The only phrase I know is the opposite one, which is the Mike Acton phrase of getting the clowns out of the car, right? If you don't think about speed the whole time, then by the time you get to where I am in this compiler, if you ever get there, which you may not, because maybe your program just being slow has consequences, like it slows down your workflow and stuff. But like, you might just have to spend a year getting the clowns out of the car before you can even be in a position to make actual interesting structural decisions about speed, because you're just not even in that neighborhood, right? And so I think that's important. I don't know. Well, and then one last reason it's important is because you get better at what you work on, right? And if you're not thinking about speed, if you're not at least trying to think about speed the whole time, and there's different versions of trying. Like, my version of trying is not nearly as intense as like Fabian's version of thinking about speed, right? But like,
and by the way, Fabian tries a bunch of different things.
Oh,
like,
yeah.
Even though he has these models or whatever, some of the time the solution is still try it 3 different ways.
Yes, I am not remotely in the same field of practice as he is in terms of writing fast code, but I exercise that part of my brain to a reasonable degree when I'm writing code, right? Even if I know I'm not writing the fastest thing, I'm like, okay, what would be faster than this? How slow do I expect this to be? When I run this later and see the numbers, I'm gonna compare those to what I thought, right? And see if I was right or wrong. And you get better at that, or at least keep it current in your brain. Whereas if you don't do that, you become a different kind of programmer slowly over time who can't do it anymore, right? If you don't do it, you will not be able to do it, right? And that's another reason why I say that craftsmanship thing of just taking a break and like, I don't care that this is only 3% of my runtime. I'm going to do a really good job on this thing. Kind of like Sean, maybe again for C, the Lexer speed matters a lot more. But that idea of like, look, I'm just going to do something that a lot of people wouldn't sit down and do to get rid of these branch mispredictions. That just makes you a different kind of programmer than you would otherwise be. And that in itself has utility, regardless of the numbers on your actual program. Okay, I know you were going to say something like 5 minutes ago, Sean. So
I don't know what I was going to say 5 minutes ago. But
yeah.
Have we sufficiently addressed? Like, originally, I asked a question about how do you know about dependencies, and we didn't actually fully address that. But I'm satisfied with what we talked about. Like,
yeah, I'll just say, okay, so some of
more.
them are identifiers and some of them are structural. For example, if you're a data struct, like a struct declaration, you need to know what your members are before you can size yourself, right? So that kind of thing as well.
Yeah, I one of the languages that I did, I had global variables could be initialized, and I did a topological sort on the dependencies between them so that they would initialize in order. But I never tried anything. I didn't go into function bodies and stuff like that.
Yeah, there is a little bit of graph theory stuff in this compiler. So like, there's a thing that finds simply connected components in graphs, but it's to break cycles in the run pipeline later on, which we're not going to get into that.
Yeah,
I kind of talked about it last week, but like, there is a little bit of graph theory stuff where necessary, but I haven't actually leveraged any for speed purposes.
No, of course.
In part because I want to reduce the amount of graph stuff that actually happens.
Well, and you have I don't want to go into it deep again, but you have this problem that a given thing has multiple dependencies on multiple stages, and that's like just a lot more complicated to express in a graphy way. So it's not surprising that you do the linear search on that. Like,
Yeah.
it's just, yeah, like it's like having to implement a Fibonacci tree for something. It's like, yeah, this algorithm will be faster if it uses a Fibonacci tree, big O, but is that going to be faster? I mean, I'm not saying it's a literal analogy. I'm just saying it's like, what? Let's just not even go there.
But that's, and that's one of the things that you learn as a performance programmer, though, right? Is like, okay, like a flat array probably is not the absolute fastest thing here, but it's actually pretty good. Like for the expected size of this array and whatever, it's like not bad.
I still point people at your talk about how to be a game programmer or whatever that one was called, where you talked about like the Doom, experience with Doom and the flat array thing, which I, despite all the crazy optimization stuff I do, I 100% agree with everything you said in that, which is, if it's not, doesn't matter, keep it simple. I mean, you had a much more complicated argument there.
Yeah, but, I remember exactly which one.
And keeping it simple is actually good performance. Like,
and part of that is knowing what simple things there are, right? So there's a few simple things you could do. You could have a flat array that like auto reallocs, and that takes time, but it doesn't happen that often, maybe, right? Or you could like have an invasive linked list situation sometimes, right? And both of those are pretty good. But you know what? If those are your two basic tools for getting everything done, that'll get you through like 90% of situations.
Yeah, well, honestly. And this actually connects directly to the thing I talked about in my stream yesterday, which was that's what made C a viable language for me. When I was working on a language to replace it, that was one of the compilers I've written.
Yeah.
I was working on a language to replace it, and I discovered that trick that I use for doing resizable arrays in C. And I put that into this file called stb.h, and I put in a string to pointer hash table. And I discovered for non-games, for just general programming, those two things were covered 90% of my problems. And suddenly I didn't need to write a new language anymore. Yeah. And remember I talked about how the fact that I wrote that HTML help system and it was very fast. And the reason it was very fast is because I just used those two data structures everywhere. Yep. And a hash table is fast. Like I now reflexively use this hash table, and some people don't like, I'll linear search an array because the array is never that big. And I just use the hash table because I have it, so I can just use it. I'm
actually starting to do that now because I use this hash table that's sort of cribbed from yours. Let me see. Like I have one here. It's basically, this is the C++ version. It's 113 lines. Like it's just not that much. This one is templated, which I don't usually do. It makes a couple of assumptions about things. But it's fine. It gets me through a lot of situations.
To use templates. So the stb.h had a giant macro that let you instantiate different types of hash tables, and I never used it because it was too much of a pain in the ass to use. And stbds has a way to do hash tables of any type now, because Pear figured out a way to do it. But it's totally a hack. Like if you're already using C++ anyway, yes, exactly. Have a vector and have a hash table. And you don't even do the vector stuff that much, I guess.
Well, I don't. I will never say the word vector in that way. It's an array.
I use it so that people know what we're talking about. But it's not called STB. It's not called STB vector. It's called STB array. So somebody has to correct all these problems. Sure.
Because they make their way into other programming languages now. So other programming languages call their arrays vectors because C++ did.
That's the nightmare. Absolutely.
Yeah. I'm more comfortable. Like I ported this hash table into the new programming language as well, right? And so that one, it's actually a little bit more robust, and it's got like an iterator, like this is the iterator for it, which is great. It's much tinier than the C++ one, and it's
does the iterator work if you delete while you're inside the iterator?
No, it forbids that.
Does it detect it and actually?
Oh, actually, no. This one. No, we don't detect it right now.
Okay. That's fine. I just brought it up.
Actually, no. The case that you mentioned, the very simple case, is detected. So if you've got a for loop and you remove from within that for loop, you're fine.
Okay.
The part that doesn't necessarily work is, when somebody far away is iterating and calling a function and whatever, and then you're down
Oh, yeah.
somewhere.
Which is the case I care about. Yeah, you call some inside your loop. You call something. The other
Yeah.
case is that you add to it and it reallocates it, and everything's in a different order. Like,
Yeah, it's a programming language for experienced people. There's maybe I definitely want to get into this is a whole different discussion, so I don't want to do it right
sure,
now. But like
absolutely.
in the same way that C and C++ didn't traditionally help you very much with memory debugging, but they're starting to now. But you could go further than where they go, especially. And part of the problem is that the way that you would memory debug in C or C++ starts being a pain in the ass when you start talking about like dealing with operating system and linkage and all that stuff, right? You could do some stuff about that kind of a thing, like, oh, you're using this hash table and then removing from it and all. There could be standards for how to deal with that for data structures generally, like conventions. And just nobody really does it because the conventions aren't there. And so we might be able to establish those, and the language could make it smoother to do them. But anyway, just this table is a descendant from that hash table.
Sure.
It makes many fewer assumptions. It's a little bit longer at like 300 lines, but it's way more versatile, and I love using this one. And the reason I like using it is because I understand it. Like, it's not a giant pile of C++ header that's impenetrable to me. Like I know the memory layout's just a linear array. There's not like linked lists that are allocated off the heap somehow. It's
You don't have to worry about copy constructors.
Yes, exactly. And so I'm not afraid of it. And so because I'm not afraid of it, I would use it the way you were talking about instead of a linear array. Mm-hmm. Whereas historically that would not be true.
Yeah.
Because of the copy constructor thing and whatever the hell, right?
Yeah.
So
I probably interrupted you to bring up the hash table example, but I paused our chat half an hour ago because I wanted to address some questions.
Okay, well, let's do that.
I'm just going to jump back to that. So this is stuff we talked about a half hour ago, and I'm just going to answer all of them, even though they might not be relevant. And I only got 4 on my screen, but I assume as soon as I scroll down, I'll see more.
Okay, let me. I'm going to take a 1.5 minute break while you start this. I'm getting cold, so hot tea is for me. All right, back in a minute.
All right, so one question somebody asked was, is there any cool optimization plans along the lines of data-oriented design for the future parts of compiler that Sean hasn't started yet? And the answer is no. We talked some about this, that the mispredicted branches are very hard to do anything about in this tree format where you have nodes of heterogeneous types. So I do not have any idea how to do anything about that in a data-oriented design way. So I applied data-oriented design in the place where I found I could do it, which was in the Lexer and kind of the preprocessor, but that's just normal code. And I do not expect the other stuff to be very data-oriented designable. I will still optimize it, but I don't think that's possible. I brought this text up to, did I already talk about it? Yeah, I did. Okay. Did you experiment with using a type union to store the AST nodes in a contiguous array? No, I just store them contiguous with variable sizes, and you have to know the size of a node to step to the first child. You could do that mechanically with a table-driven system. So if you want to be able to do that without switching on the type, it is possible, but I don't have a code that needs to do that yet. Have either of you ever implemented an optimization that has proven underwhelming or actually slower than what you had before? Okay, I assume you don't mean a compiler optimization, but optimizing the code, etc. You manually optimize the code. And the answer is yes. It is totally, these days, more than ever, it is normal to make a change to your code that you think might make it faster, and it does not make it faster. It can be data dependent. Maybe with the data that you're testing, it makes it faster, but the full real world, it makes it slower. Or this is an issue for me as a library writer. Maybe on certain workloads, it's faster, and on certain workloads, it's slower. And it's like, well, do I release this for the benefit of the people for whom it's faster, but then some other people it becomes slower? It's hard to say. in this thing, I actually mentioned a case, which was that I did this. I removed the array bounds checking by doing this page fault handler, and it did not make the Lexer any faster. I think it actually made the Lexer like 0.1% slower, but I decided I didn't mind that loss. I thought that compilers would turn switches into jump tables. Doesn't that mean they're equivalent to transition tables? They wouldn't have branch mispredictions. Compilers will turn switches into jump tables. The jump table branches to a different address. And one of the things that branch predictor does, it's not just true or false, does it branch or not? It's where does it branch to? Because it needs to figure this out way in advance because of the way things work. So the branch predictor is actually predicting what address it's going to end up at next. And when you have a switch statement that can go to lots of different places, you're pretty much in the random case where it's very highly unlikely. Most branch predictors just have one address that they can store. The classic model, I don't know what modern branch predictors, modern branch predictors do, but the classic model is that they store a single place that it might branch to. It either branches to that place or it falls through, or it just stores a single address. And that basically means because it can branch to lots of different places in the switch statement, it's basically always going to only have one place that that branched to like the last time, probably.
Sorry, I should have put your screen up before I went to get a snack.
It's okay.
I have done that now.
I didn't show anything from it, so it's fine.
Yeah. Well, you can now. People will see it.
So yeah, they're just going to always branch mispredict every time on the switch. The transition table stuff is a memory lookup, and that, if it's in cache, is just always going to be fast. So if the transition table isn't in cache, then it's going to speculatively execute it past it, and it's going to be wrong. All the stuff it computes is going to be wrong, and it'll have to unwind and recompute all that stuff. And if that's assuming you're on a processor that predicts the cache misses, or it's just going to halt and wait. So either way, you're waiting for that to resolve. But if the transition table fits entirely in cache, the hardware is prefetching the string that you're iterating through, and so basically everything is living in cache, then you don't pay any costs. The transition table is just a cache table access. So they're not equivalent at all. Okay, that was 3 questions I got through. No, 4. Yeah, that was 4.
You can keep going if you want.
Well, so I'm scrolling down, and I'm not being highlighted anymore.
Okay.
Okay, here I hit a bunch more.
Okay, cool.
Does it seem interesting to compute the result in a branchless compute all possible results type of way? Well, so I in fact mentioned this in the lecture. After I've found a token, what I do at that point is I need to actually totally change this. I had a branchless thing that had 2 possible things it did. The idea there is that in one case, it needs to write out the information about where in the source code the token is, and in the other case, it doesn't need it. It just needs the first and last character. So what it actually does is it branches between those 2. It doesn't always write them out, which is what I said before because I forgot. There was a branchless version that always wrote both versions of that out, and there's 2 independent arrays, one array to store first and last character and one array to store start point and length. And it would just always write both of them, but it wouldn't increment the array point. It would actually write to a dummy entry. And so it was branchless, and that was slower. So I just used the if, even though I don't know why it would be predictable switching between those, but it was. So so you have to be careful trying that stuff. You have to test it and see whether it's faster or not, pretty much. But a switch statement replacing is very, very likely. We have a lot of experience with this with writing interpreters. And that's sort of where I get a lot of this ideas from, is because I've written interpreters. I've written like 10 interpreters over the last 30 years. I've seen how it's evolved, what you want to do to make interpreters fast. I've got more questions here. I've noticed your character classes aren't pre-multiplied. Yeah, that's I think they are, and I just don't do it syntactically there. I think I multiply them somewhere else, but I'm not 100% sure. And that's just details that has to do with the paper that I mentioned that I'd written about it. Try to scroll down. Okay, I don't see any more from 20 minutes ago. There may be stuff more recent. Oh. Is your preprocessor between the lexer and parser or used by one of those? The preprocessor lives at the front. So this is, I can talk about it, but it's kind of off topic. I don't know if.
You know, I have a chip on my shoulder from a comment many hours ago.
Go right ahead.
Well, there was a thing, I think you saw this and replied to it too at the time, but there was a thing talking about the paper about the ludicrously fast JSON parser or whatever, or was it?
I did not reply to it.
Oh, somebody wanted to link to this paper, and I just didn't want to distract us from.
Was it SIMD JSON or was it some other?
Yeah.
Okay.
And I mean, the thing about that is like, okay, that's all fine, but there actually is no such thing as a ludicrously fast JSON parser, and the reason is that the format sucks. Like, if you actually, I mean, it's all fine to like, well, you know, as you were doing with Iggy as well, like. There's such a thing as coming along and being presented with a less than ideal situation, right?
And you just have to make it work.
And you just have to make it work. And to some extent, you have to do that with C as well. Like there's just going to be things that you wish, like with includes or something, like you wish it was different probably, but you're solving that particular problem now, right? The thing is, if you can change the problem to something that is going to be much better and much faster, you should do that. Right. So unless you had to use that file format, you should just use something different. And what that is depends on what you need to do, right? And then you can make a ludicrously fast. Okay. Ludicrously fast is like something like what people are doing on the PS5 right now, which is like at the bandwidth of the
SSD.
The compressed data coming in off the SSD, which is being decompressed in hardware, you are able to get that usefully into memory. And that's not just parsing, because like the thing with JSON and XML and all that is people conflate parsing, like parsing it or deserializing it into a tree structure is not the whole parsing job if you then have to go search that tree structure for the information that you actually cared about, right?
Yeah.
Which is what happens when your data format is too general, right? And so, and validating it and whatever, right? Like, so all that stuff are problems that in many contexts you wouldn't have if you used a different file format. And so, so someone's asking, what is it with the format that makes it slow? It's just, it's very general. And I mean, there's this trade-off, right? Like something, like if you were deciding on what this format is, and the way it worked was you're in a committee and everybody gets to say, but I want to do this and but I want to do that, then you end up with something that's not really that good for anything, right? It's like you have the joint strike fighter of file formats. Now I don't think things like JSON are that bad. They're not quite joint strike fighter level, but they're not good. And so let me. I don't have this link handy, but I want to pull up this this thing from Twitter today. Did I retweet it? Hopefully, yes. So, wait, where's the link to? Did they take out the link? So I'm looking for the source code to this lerp that was in C++20.
Oh, yeah.
But the thing I retweeted doesn't have the link.
I never saw the source code. I just saw the documentation. I saw the documentation for it.
Okay, I sent this to people in email today, so.
Oh, I may have it. I don't know.
I think it was just.
Nope, I don't.
Jeff.
Yeah. Yeah.
Sent. Okay, I can't believe, maybe I didn't retweet it or maybe somebody deleted their response.
You can stop screen sharing me, by the way.
I don't know, we might need it.
Okay, yeah, that's fine.
Oh wait, I just tried to drag this to another monitor and it again didn't work.
In fact, I brought this thing up because I had a quick comment about it that was relevant 15 minutes ago. But...
So this is lerp in the C++ standard declaration now, right? Lerp between A and B by a parameter. and
I'm going to have to put this on my main monitor. Oh, okay.
and it's handling like infinities and nands and like all this stuff, right? And it's 110 lines of very slow things when the actual thing, like literally every program I ever wanted, or every program I ever wrote, wanted a one-line definition of this thing, right?
Yeah.
And
Yeah.
that's much, much, much faster than this, and just much, takes less time to compile, and wasn't templated, and whatever, right? All these things. This is what happens when you try to be very general, because they're like, well, what happens if somebody passes minus infinity as the
Yeah.
t parameter, right? And it's
It-
like,
it's it's like in C, you would just say it's undefined or it's implementation defined. Except I don't know that the current C committee would do that. But
or I mean, you just define the correct use of this function to be the following, right?
yeah, right. You just say if you pass in infinity or nan, it's. So it's interesting because the documentation actually says that it's defined as a plus t times b minus a.
Wait,
I don't know
somebody.
if that's the actual implementation here. No, they use 1 minus t. Yeah.
Oh yeah, and somebody says it calls abort at the bottom. There's an. I never noticed this before. There's an impossible case, right? That
Yeah.
but it's in the switch statement, and it frickin' calls abort, which means you need to link abort
Yeah.
and use the standard library to use this function. Thank you, everybody. But the point I wanted to make here is like, so we posted this on Twitter, or I guess I didn't retweet the right thing. I'll have to do it later. But there were people in the thread saying, well, you obviously don't know how IEEE floating point works because you need to handle these things and stuff. And it's like, well, no, I mean, that's very wrong thinking, right? Because you encumber yourself by using this. Like if I had put this in my games and I didn't know better, I would have had to work way harder on other parts of the games to like get them fast enough to make up for the fact that I was using this. Like lerp is used everywhere, right? And if you don't understand how much of a penalty you're taking here, it's a big problem. It's a big problem. And so I don't know. I don't think this sort of thing should be in a standard library. Like that's a whole different discussion, I guess. But I don't know, man. It just made me tired looking at this. Like this is exactly what's wrong with C++, and they just keep doubling down on it. So that by analogy, this is kind of what JSON is in some sense. It's like, here's a file format that does all these things and is general and handles things. And it's like, but you don't actually need that almost ever, right?
Go ahead.
Well, and then by, I always
just,
like...
I just have something to say when we're done with this.
Okay.
So before we leave this page, I have something I want to say, but finish yours.
So my last thing is I like to bring it back to physical analogies sometimes. And it's like, you could look at a bicycle and say those wheels are so flimsy, they just have spokes. And if you kick it really hard, the spokes will bend and the tire can be popped, right? And like, by the time you fix all those problems, you have an armored solid steel bicycle wheel with like tank treads around the outside. And then it's really hard to ride your bike, and you don't want to ride your bike, right? Because you solved all these quote problems, unquote, with the bicycle wheel. Now there are high technology ways to make a better bicycle wheel, but that's different from like, making an armored personnel carrier wheel, right? It's like a different thing. And C++ doesn't understand that. End of rant.
So I just had a random comment about this that I wanted to point out. So if you look at line 19 there, it's doing what amounts to an FMAD, like a multiply add,
Yeah.
right? But there's a different definition for it, which you can see at line 10, where it does not correspond to a floating point multiply add.
Yes.
And, so it's potentially a little bit slower. And I was wondering if they were going to do this because, so there was this classic bug, I guess I saw it probably on the old new thing, Raymond Chen's blog, where he was talking about how people compute the center of, I don't know, it's a GDI thing maybe or something, how people compute the center, and it's X plus Y over 2.
Yeah.
And the problem with x plus y over 2 is that it can overflow.
Right.
And so the correct way to do it is like x plus y minus x over 2, or so, I don't remember. Like, and that was on integers. And obviously, floating point is not going to overflow. But I was wondering what they were going to do about the case where if you lerp and you use the definition at line 19 and you set one input to like max float positive and the other one to negative max float, then when you take the difference, it does in fact overflow to infinity.
Yeah.
And that appears to be what this code is meant to do, because if you look what the circumstance that makes it choose the first computation is, it's that they have different signs.
Yeah.
So-
I mean, I sort of followed it, but honestly not that closely because, you know.
Well, this may be doing other things. The weird thing is that they claim that it's the 99% case put it first, unless they mean that the finite mask. Maybe they mean that's the finite mask. So the 99% case put it first. It's referring to that. But anyway, it's just like, even ignoring all the NaN and the finite stuff, they have this extra thing that, to a first approximation in my mind, is to deal with the fact that the subtraction could overflow.
Yeah, I don't understand that 99% case. That almost
I think that's
looks like an
referring-
incorrect comment.
I think the 99% case is referring to the if above it. This is the case that is, so of the if, there are two cases for the if then and the if else. And the then case is first. I think that's
so. This is with this.
Yeah.
Put it on the same line then, bro. Like,
I actually write it that way as well. Like
well, that's fine, I guess.
But they've phrased it because the very next thing is code that's doing an if and returning. It's, yeah. Like I do the same thing, but I do it in a way that's more clear. Anyway, that just amused me that I thought about, would they avoid that bug? And the answer is yes, they avoid that bug at the cost of not using a floating point multiply add. So yeah, that could is, yeah.
But this is so silly. So looking at this switch statement again, down at the
Right.
bottom they call abort if it's 111.
Right.
And they literally had an if statement up here, if it's equal to 111 return, right? So that's why it's impossible. But like you're introducing dependencies in your code for that.
Yeah.
For the fact that your CPU didn't correctly return you at the end of the if statement, or like you could make the argument like, well, as you maintain the code or whatever, you make a mistake. But like that's not something that you want to link extra runtime code for. That's really bizarre and weird, you know?
Yeah, that dependency is pretty annoying. However, the one thing I will say about this function, as bad as it is it probably could be worse if it were boost lerp.
Oh yeah, dude, if it were boost lerp, you can't assume a Euclidean space, man. You need to pass the metric as a template argument, okay? And I'm not kidding.
You're
That
not
was on their
joking, I
example
know.
page. But actually, if you scroll down this page, I mean, it's impossible because nobody's going to type in this long hex number from video. But
Yeah,
there's people defending this on here about
people in
about,
chat.
like, yeah.
Should I just ban them all, or shall Casey just ban them all? I'm kidding.
Yeah, I don't know. Anyway, this has been a really long session, so maybe we should start bringing it to a close. I don't know exactly.
I mean, you said your brain power was low or whatever, so I didn't know if that meant you wanted to get out of it or
No, it's a little bit higher again now. It's just this isn't my best day. Is all I'm saying.
Sure.
Like broadly across the whole day.
Well, so the question I had tried to ask before we bring it to a close, question I tried to ask and I didn't ask it properly is there anything going on in this compiler that is optimized that is worthy of attention that I could quiz you on? But maybe you just want to bring it to a close instead.
Not super much. Like there are basic things that happen, right? So for example, I just don't use the heap almost ever, right?
You
Unless I have to.
linear allocate from arenas or something?
Yes,
or?
and every piece of the compiler has its own arena. There's arrays that we use all over the place. Some of this is very sloppy, and it's just like my first approximation at being fast, right? So just like there's a hash table here, or this isn't the C++ one. Let's go to the C++ one. Oh, this, I guess that's in, maybe there is no allocate function. I don't know anymore. It's probably in a C file with arrays or something. Oh, so you'll note here, when we allocate stuff, we're using this array pool, right? And what's that? Well, it's the same place that the generic re-expandable array gets its memory, and that's like a thread local, there's a thread local linear allocator that you can just assume is there and never freeze anything, right? And so you have to, use that at your own peril. Like if you allocate way too much memory through that thing, you might regret it. But it's a general tool that I just assume exists and we'll just use it, right? But so, right, I'm getting without mutex here because it's thread local. And that's a lot faster than what someone would naively do who learned how to make trees in college, right? So that gets you a long way, actually, toward having a faster compiler. But it's not like rocket science either. And it's not even as clean. Like, I maybe should have pools for like stuff that's going to live a long time in the compiler versus stuff that's not going to live a long time. And I don't even do that right now. I just don't ever free any of it until we exit.
It's unfortunate that thread locals aren't as fast as they could be, but
yeah, I actually honestly don't know quite how fast they are. Here's a thing, right? This is an issue that we have in the actual programming language, which is we have this context struct, right, that gets passed around. So it's not an object-oriented language. So in the place where C++ will pass, two methods, it'll pass a pointer to the this, right, whatever that happens to be. Usually that'll be in a register. Of course, it's compiler dependent, what happens, I guess. Except maybe not, because maybe now that people are agreeing on an ABI, maybe for x64, that's like, no, I don't freaking know. But we have an equivalent thing, but it's not for objects. It's for the context, which has a lot of common stuff, right? And so one thing that has some things that you might, like every thread has its own index that's stored on there. Like you can set the allocator and logger, and those are on the context, and that's pretty much going to be hot all the time, so you don't have to worry about the penalty being too bad for those. There is, of course, these are function pointers, so you would take maybe a mispredict penalty if you changed it a lot, but you probably don't change it a lot. And then
as long as you're not changing it, it's fine.
And then, so I forgot what my point was now. There was a reason I was going to start. Oh. Okay, so this is where if you're going to replace the allocator, right, then it's very convenient that you just replace these pointers, and then you just call to some subtree of code, which is maybe some library that somebody besides you wrote that didn't even know you were going to substitute the allocator, and it's fine, right? You don't have to worry about it. The author of the library doesn't have to do a bunch of work to let you replace the allocator. It's supposed to be just low effort for everybody, right? So that's fine. The problem is, because this is passed in the calling convention of the programming language, you actually lose it right now if you call out to C and then call back in, for example, right? Because it's passed as a parameter, and C doesn't understand that, and neither will any other programming language. And so it's not that inconvenient right now, because you honestly don't do that very often. But there were cases where like if you set a logger even for something, or I don't remember exactly what the specific cases were, but there were cases where it was a little bit gross, and you had to know in the callback kind of who would have caused you to be called back and set the right things or whatever. Whereas if we change our mind and say, actually, instead of this being passed as a parameter, if it's thread local storage, you don't actually have that problem anymore. So I'm a little bit on the fence about that. I don't actually exactly understand how thread local storage works. It's probably not that complicated. I just haven't thought through it ever. So we don't actually support it yet at all. And that'll make people grumpy if we don't support it at all, probably. So we should support it. And then it's a question of, is this there or not? And so part of the question is how much of thread local storage being a little bit slow is the language and or convention's fault and how much of it is like the CPU's problem, right? And I don't actually
Well,
know.
I think the problem is the ABI, the platform ABI. So I don't know about anything other than Windows, but and I don't actually know what's going on in 64-bit. I know what's going on in 32-bit, and my impression was that under Windows, the 64-bit uh, interface to thread local storage looks similar. Um,
Hmm.
the way it worked, I don't know if you care about the details.
Well,
Um,
how slow is it, for example?
well, so the way it works, my vague understanding of this is that the FS segment register is different in every thread, points to a block of memory that is unique per thread. And the block of memory then stores pointers to the actual place where you actually get to store your thread
Mm-hmm.
local data.
Mm-hmm.
So it's doubly indirected.
Right.
Um, the problem is that, like, because of DLLs or whatever, you can't allocate that stuff. The linker doesn't get to see that stuff, and so the everything gets indirected through functions that do TLS. Like, there's a thing you can do this to do it not compiler based. You can call this function like TLS alloc, and it returns you a handle
Yeah.
or something that then is dereferenceable into unique memory per thing.
Yeah, that sounds terrible.
And Casey will correct me, and I'll repeat it if I see him correct me. Uh,
Yeah, he says it looks at the segment address and goes to a table and gets the value. It's not what you want. Yeah.
and
Do you guys have any estimates on cycle cost?
Well, I mean, it's just an extra dependent read, so if everything's in cache, it's not a big deal, probably. Um, my thought was just that, and there's historical reasons why they had to do it that way, right? The whole FS thing was a hack, but what I was thinking about was that, like, the DS register points to your heap or whatever, and they somehow make that work for DLLs. So, like, why is there not just a thread local heap that the FS register points to that is treated the same way a normal heap is, except it's got multiple copies? Like, why can't the linker and the loader just cooperate to allocate memory in the same way the static memory of the data loaded with a whatever you call it, the text segment, the data segments in the file are? I don't see why the FS couldn't just do that. For historical reasons, they couldn't fix that for 32-bit, but it seems like the moment they did 64-bit, they should have just switched to that. And I don't know, maybe on other platforms they do something different.
Yeah, I don't actually know.
Yeah,
That is an area where, I mean, that's the thing is, like, I wish I was more knowledgeable about that stuff, but most of my time is spent on the higher levels of the compiler and the game. So, like, I never dig down into that stuff, like, it's very weird because I do stuff that is ostensibly very deep, but in the shallowest way possible. So, like, I wrote a frickin' machine language emitting backend for this compiler, right? Not even the way, like, most people would do it. They would output assembly language and then have an assembler do it. And it's like, nope, we're not doing that because we want to be fast. We just output machine code. That is a giant pain in the ass, right? It's less of a pain in the ass if you're not remotely trying to be efficient because you don't have to worry about all the different forms of all the instructions. Like, I would just pick one and say, look, we're doing 64-bit register version for this weird instruction only, and it's fine. But, like, that's ostensibly a more deeper systemy thing than most people do, except that I did that in like a week and then never looked at it again for like a year, right? And so I don't ever get good at that stuff, is all.
Yeah. Let's see. There was something else I wanted to talk about, but I don't remember what, so it doesn't matter. One thing is, in my code, I have this context structure that I pass around everywhere that's not your kind of context. It's just the context of the current compilation. It's like, it's got all the pointers to all the arrays and stuff.
Sure.
And there was this whole thing where back on 32-bit, because the x86 could have inline 4-byte constants, could have 32-bit addresses inline, using globals was really efficient. And I would have just made that struct to be a global, and you could, get to the data pretty efficiently. And now I don't I don't. I'm under the impression that you don't do that in 64-bit. I don't even know how it accesses the data, global data, if it doesn't have 8-byte offsets or avoids using 8-byte offsets. I don't know if it leaves an ES pointer pointing to your global data. I have no idea.
Everything I've seen just literally loads a register, or loads from global data into a common register and uses that.
Like keeps a common register pointing to the global data, you mean? Or
well, I mean, it's weird. So even stuff that you wouldn't think is that crazy. Well, maybe you look at machine code more than me, but like I was surprised. I was vetting like, okay, what do I do in different cases versus what is Visual Studio output, right? And like to negate a floating point number, it actually puts like a 64-bit floating point number. It actually puts a 64-bit value in global data that consists of the high bit of IEEE 754 with the other 63 bits 0, and it like XORs that. And it loads it into a register, and like an integer register, I think.
Right, because it can't have
maybe
byte.
Or no, I think it is a floating point register. But yeah, but I would have assumed naively that there was some way to like encode the constant in the instructions, and it's like, no, you just don't do that. You like pull it out of memory.
Casey says you can use RIP relative addressing for globals. So I presumably that's only for read-only data.
But that would be then, so like last I checked, if I actually stored, I did tricky stuff at one point. Like I tried writing comments inside the machine code and like would jump around them, and because it would be right there, and then I hoped that like I could just go into byte mode and read them, and like dude, everything freaking crashed. Like Visual Studio like barfed to high heaven as soon as it wasn't like valid machine code, because it was just like there was some ASCII in the middle. And I think actually the CPU didn't like it, because it's like prefetching those and decoding them even though it can't get there.
Put it before the function, but
yeah, maybe that would help. But like, is that a thing you can do? Like, would you use RIP relative addressing and actually just store the value right before the function, like in the code segment? Because otherwise, why would it be relative? Like,
why would we? Do we map executable stuff to not be readable? I assume we do allow it to be readable, not just executable.
I don't know.
But yeah, if you put it before the function, you can still compute what the offset to it is. Negative offsets are fine. So I would think you should be able to do that. Although, yeah.
Someone's saying ARM does this all the time. So I guess at least in ARM.
But if it's a writable value, you can't do that. So yeah. You can do it between code and data pages. Oh, I guess you just intentionally map. You just intentionally say, well, here's 4 megs of code and some storage before it at a known address that you will map.
Yeah. I mean, I guess the point is, as long as you can fit it into 32 bits or whatever.
Right, exactly. Right. You use 32-bit offsets. You don't use, you're not trying to pack them to 8-bit offsets.
Yeah. I mean, 16 even seems like it would be very rare. You'd almost never be able to do that consistently. But 32, maybe.
Yeah, I think that's 32 is 4 gigabytes. Most of the time, your code is probably smaller than that. So yeah, I guess that makes sense. But so what I was going to say is,
how big is an Unreal Engine executable now? It's pretty big.
Oh God! Well, like we're talking about real programs, not
not Unreal programs.
Yeah. The thing I wanted to say was I have this context pointer that I pass around to everything. It's the first parameter to everything. And you mentioned to Casey in your compiler talk, I can't remember. Oh, it was, you mentioned even just putting an extra parameter on something is an overhead. And so it would be nice to have that context pointer just be register allocated. But the GCC, in GCC, you can register allocated global, but the semantics aren't what I want for my thing. Mm-hmm. So one of the things I may do is put in an extension in which is register allocation of a global pointer that has the semantics that I want. And then my compiler, if I self-host it, will get an optimization advantage. But we'll see.
Yeah,
it's just a super common pattern to have that pointer, that context pointer that you pass around everywhere. It totally different semantics than yours, but yeah.
Casey's also saying, hey, you can use the segment register. You know, I kind of filed that away as something I don't think about anymore, but maybe I
Wait,
should.
so you just access something. So, but that relies on the loader to actually have loaded your data into the bottom 4 GB. I guess maybe they do that by default.
I don't even know. Anyway, something I will look into when I start wanting to generate better code, which isn't going to happen anytime soon.
Yeah.
I just have my to-do list is too long, man. Anyway, if I pop up a few levels, you were asking like, are there things that I do that are fast, right? And maybe we did just sort of go off on that topic, but honestly, no. Like, honestly, the answer is compared to what people at RAD do when they want to make a program fast, I've done almost none of that here. And yet the compiler is faster than everyone else's compiler.
Yeah.
So, like, what does that say about everybody else? Honestly, is the point. Even, you know, compilers for languages that should be pretty fast, you know, like, well, I don't know. I don't know if there are those anymore. Because, you know, C++ has this combinatorics problem with the header file. Which again, I did email Bjarne Strostrup back in 2002 when I was working on an Unreal Engine project, and I said to him, "Look, there are people whose entire job for 6 months is to try to make the build go faster. It would really be beneficial." I was quite respectful, I think. In my memory, I was respectful when I wrote this email and said, "You know, the thing that C++ could actually use is some way to mitigate build times and make them faster." And his reply was, "No, you just don't know how to program. That's why things are slow." He said that to me in 2002. And like 18 years later, they're still working on actually finally fixing this problem. I have that email somewhere backed up.
Who was it?
Bjarne Strostrup.
Oh, yeah, okay.
Or I actually have 2 emails from him.
I shouldn't laugh at that because it's not a surprise. Yeah, so yeah.
As my only, after that, I was like, okay, I guess that's my interaction with this guy, you know, whatevs.
Oh.
Yeah. I don't know, maybe we're done today.
Yeah, there are questions we could answer, but I know you're getting tired. So, or not
I am.
tired,
I am
but-
getting kind of tired. And you know what? Our general plan is that we're going to do another one of these next week or sometime on gameplay stuff.
Right.
I wasn't quite ready for that today. It would have been especially not good given how tired I am today. But things are looking up in this part of the game code that I'm working on, and so. By next week, we ought to be able to have a good discussion about this. And this will be something good, like, this is relevant to gameplay stuff that Sean has worked on, right? So he kind of knows part of what the groundwork is for this too.
Yeah, and hopefully, I guess hopefully, like one nice thing about what you were doing with Casey was going through the code and getting somebody else to ask questions about it so that, you know, it was as opposed to just the freeform discussion we just had. So I don't know if it'll be more like that or not, but there was nothing wrong with this discussion. It's just like, that was sort of that's a very interesting thing to do, I think. Like,
Yes.
That was a very valuable thing. So maybe it'll be more like that.
Well, I also, you know, since we have this idea of like, hey, this kind of a session is a thing, like I can just keep an eye open over time for like, oh, this thing will be interesting to talk about.
Yeah,
and
absolutely.
Do a thing about it.
Yeah, I'm happy to do more of these, and I'm not going to complain if you do them with other people.
Who else can we recruit for this? Does Sean McGrath? I noticed he doesn't really stream anymore, or does he? And I just don't know about it.
He's just started streaming again a little bit, I think, but
Okay.
I don't know if he was. I think he did.
I'm
There's
not
obviously
sure.
there's Fabian.
Well, we'll figure it out. I'm sure.
There's Chris Hecker.
I don't hang out with Chris right now. That's
sorry.
not a thing. No, I mean, it is what it is.
You could try to do Jeff, but I don't know that he has the. right
Jeff
mindset.
is kind of in a different universe from me.
Yeah, exactly. I bridged from you to Jeff, but yeah.
Yeah, I don't like. I also feel like Jeff's just doing a lot of movie stuff these days, and that's where his head is.
Oh yeah.
I don't know how much that actual reality is, but
Well,
maybe
yeah.
that was last year, and he's done with that for now. I don't know. but yeah, like it'll be fun to do more of these. I wish I'd been a little more awake because I'm sure I would have been sharper, but hopefully this still was sufficient for the people out there. I can do a couple last questions real fast because I saw a couple came up when we sort of implied. Is there any linear algebra in the compiler? There isn't really. Again, I don't know if you're not doing like weird constraint solving or something. I'm not sure where you would use it. But maybe there's a smarty pants way to do that.
There are some like non-linear algebra math tricks, like replacing divides with multiplies, divide by constants with multiplies by constants.
Yeah.
And stuff. So there's math stuff that can happen in a compiler. It's not going to happen in yours because that's an optimization. So
Yeah.
you just leave it to LLVM.
Or like, I mean, I could imagine like a Newton-Raphson iteration or something where like you have a priority queue. Like that's the thing that happens, right? You have a priority queue and you're trying to pull things off the priority queue, but estimating the priority is expensive. So you like approximate it with a linear thing. I don't know. But no, that's not going to happen anytime soon. Can I do something on control theory stuff in games? Well, I mean, just like with this compiler, like nothing is that good. Nothing in the game is that good control theory wise, in part because I've had bigger problems. I think I want to do a little bit more there before it ships, but I'm not sure it's ever going to be that smart. I did have this thing where I got into an argument on Twitter a couple months ago with someone who was telling everybody that, I forget what the name for it is, but like, just the thing where you raise something to a power less than 1 every frame in order to get to converge, or I forget exactly what it was, but that thing, the thing where you multiply a value every frame in order to get it to go somewhere, and it's super frame rate dependent.
Yeah, you did an inner product column.
Yeah, way back in the day. But then I also, so I got into this argument and this person was like, no, it's totally, look, let me show you at 5 different frame rates what the results are. And like, there were different dots in different places all over the screen, like trying to track the cursor. And I was like, I actually spent, while I was hanging out in a garden in San Diego, I spent, like an hour, probably not an hour, half an hour, just writing a very simple, like, I don't remember the names for all this stuff, but an inertialess, I guess it's 0th order controller or something that just uses a midpoint step to reapproximate like what the velocity would be. And for almost all frame rates, they were like exactly on each other. Like one of them was off by a little bit.
I should have interrupted you when you first started answering this question, which is, what is control theory? I know.
Oh yeah. People don't know that. So the word cybernetics predates computers. Of course, I think it comes from like warfare initially. Like people were trying to steer rockets before we had digital computers, and probably trying to steer other things. And so like cybernetics is the word from, cyber is from Greek for something. I think it might be, it's from someone who steers things, right? But the modern name for what used to be called cybernetics is control theory. Because now if you say cybernetics, people think you mean like AI from 1980s science fiction movies or something, like the Terminator or something. So it's a discipline that's existed for a long time, and it's just like, how do you steer a value toward another value? If it's not that simple, like if there's momentum, or if there's momentum plus friction, if there's like other kinds of feedback on the thing, it's very easy to overshoot. So if you do this very simple model, like I want my value, I want my puck to go toward this point over here, but you have velocity and acceleration, right? That persist. It's actually very hard to hit the puck without accidentally orbiting it or overshooting or oscillating or all these things, right? And so you have this thing called a controller that tries to solve that problem. And there are various kinds of controllers of various levels of computational complexity and various levels of how easy or hard they are to understand to solve various levels of difficulty of these problems. I don't know how good of explanation that was. But they're usually like not that big of a piece of code, you know, like the one that I wrote it was probably like 20 lines of code to do like in as frame rate independent way that I could in like half an hour, follow the cursor on the screen at a given speed, right? And that was like 20 lines of code. It wasn't like there are things you can use like numerical integrators, which are off the shelf ways of, well, can be off the shelf in terms of code, but are also just off the shelf algorithmically, where you write your own implementation of ways to. Physics is sort of an integration problem, right? Like converting acceleration into velocity is like adding up little pieces of acceleration over time, and converting velocity into position is adding up little pieces of position over time. And so when those functions are complicated and change over time, possibly sharply, you can use higher power integrators to help you with that kind of conversion. I don't know. Do you have anything to say about this, Sean?
I think you've covered everything I have to say. I mean, it's a hard problem.
Yeah. And also, I almost never do this, so I don't think about it that much. So there might be a much better explanation that somebody can give you.
Yeah, I just ran into it when a long time ago, I was writing a game and I needed AIs to steer their hovercraft to chase other hovercraft. And the problem is that, one issue of one way this can work is that you have a physics system and you actually have to compute what's the inputs to put into the physics system. But even if the AI is just directly controlling the orientation, you want it to behave physically. So you want it to have, angular momentum of like 1D, right? What way is it facing? But you want it to like accelerate and slow down its turn. You don't want it to instantly snap or not even accelerate. Just suddenly be turning and suddenly stop turning. It might be subtle and you might not notice it. And that particular one is interesting because it's got wraparound. So that was the one place where I started tackling this problem and realizing how interesting a challenge it was.
Yeah, it's a lot harder than you would think. And a lot of game programmers they just run into this kind of thing by accident, right? They don't even know it's going to be a problem. Like how would I steer toward a point? Let me just try this. Let me just try that. Because it's easy to not have this in your computer science education, even if you have a bachelor's degree, right? Like you might have it, but you might well not. And so, yeah.
So, and for people, because I see in chat, people are talking about PIDs, or
yeah.
I can't even remember what it stands for. Integration.
Well, PD is proportional derivative, right?
Right. Okay.
I don't remember what the I is.
And so a classic approach is to sort of apply filters, like you can think of them as like springs or something. And then you is it critically damped or is it, and it's just like that way of thinking about it was very foreign to me. It was hard for me to reason about it and understand it. So I was writing code that basically tracked an acceleration and a velocity and had like a max, talking about angular velocity, like this 1D rotation thing. I was writing code that kept track of an angular velocity and was like, here's the maximum acceleration I'm allowed to apply, and here's the max velocity, and let me solve this thing over the time it'll take to get to the thing, and then apply this much of the time step of the solution to that. But so it was actually doing like a quadratic equation kind of thing to solve this this thing with a maximum acceleration problem. And the results from that are fine. Like it wasn't, you got, if you set those numbers reasonably, you get reasonable behavior and you don't have to worry about oscillations and stuff. But that was my approach to tagging. I'm not saying it's the right way. Maybe you can make the PIDs work. It was allowed me to do it without, I understood the theory of that. It just, it was too indirect. The numbers didn't have meanings for me.
If I had the time to do little programming projects, which I don't, I feel like that would be a really good investment, is to just get good at that for a month.
I actually tried to write an STB library that was a constant, a max acceleration controller, but you can't do it in 2D. That solution space doesn't make any sense. It only works in 1D. I mean, I'm sure you can write something, but I think the filter approach may be the smarter approach in 2D.
Yeah. I mean, just even that level of having that level of experience like solidified, like, oh yeah, I have in my head what it looks like
Sure.
when I do the filter
Oh,
version.
if you actually
versus
investing the
yeah.
time on the filter version, so now you know. Yeah, maybe that would be worth it.
And I maybe kind of want to do that for the current game because, like, it's got a little bit of controller stuff in it already, and
Because
it's
you're
not
trying
very
to
good right now.
Is that like when you're trying to get multiple steps done quickly to catch up or
Well,
something?
even just for one, like if your guy is going
Oh,
to
just
move
for
from
one.
one square to another, let's run a game. If your guy is going to move from one square to another, there's just acceleration and deceleration placed on that the animator sets up.
Right.
It doesn't look like much, but like this actually looks much better than a straight linear interpolation, right? Obviously these graphics are not final and whatever, but
Are you saying that the animation is you're saying the engine is applying an acceleration deceleration and the animation
yes,
is relative to that position basically?
kind of, yeah.
So
Like I
like
guess he
the
tweaks
feet
the
aren't really
animation.
played like because the normal way to do that is that like you make the animation just have a linear velocity and the foot placement is placed so that it's stable when you have the constant velocity or something like that.
Yeah,
And
we don't do it that way, but
I
in
don't know,
the
that's normal. That's the way I think of, I guess.
yeah, in the animation graph right now, it's like data driven, so you can
Right.
say like take this long to accelerate to full speed. And then I guess he approximately matches that to the animation. That might not really be the best workflow. Like we
Does
probably
it,
have some foot slide right now because I changed
or
it.
does the animation actually play slower or something? Like, does the animation itself accelerate and decelerate? Do you know, or does it just play the
Um,
animation at full speed and accelerates the position?
well, definitely when I go into running mode like this and we're just
Yep.
going super fast, then I play the animation faster. But
Oh, okay.
but during normal like this speed of movement, I don't think so. But anyway, so this is a little bit of a controller just to do the acceleration and deceleration, and it tries to also, I mean, there's just some constraints on it involving like transactions, gameplay transactions, which is what we'll talk about next time. But like this thing kind of has to take an approximately known amount of time, you know, and to go from one square to the other, because we need to predict in advance what time he's going to cross the midline
Right.
with reasonable accuracy. And right now, I actually just frickin' run a loop. When we create the transaction, I say, do 500 time steps of running the controller function and seeing when he crosses the line. And it's super stupid. So that's something that could be improved. But yeah, I don't know. It's like, so for things like when he's cornering like this, I was actually working on this on stream the other day. When he goes around a corner, like he doesn't actually, he's pretty close to the middle of the square, but there is actually some slop that I let it have. So it is actually like interpolating a 2D vector around. It's just my current solution is pretty tight because that's just the thing that I found that worked okay, like the set of parameters that worked okay, that didn't let you go, well, there he went pretty far outside the square. But you might not notice that because I only notice that because time is artificially slowed right now. This looks a lot better than if he was pinned to the midline of the squares, but it doesn't look that good. So I would like to have some parameters I could tweak that were the make it look good parameters, right? And that's kind of what you want a controller for, and I don't exactly have that. That's all. So, but the framework that this is built on is strong enough that we could do a lot of experimental things with the actual controller, and it wouldn't endanger the core gameplay, which did not used to be true. So we'll discuss that in more detail next time.
When he comes to a stop and it's really jerky, is that because you ran into a wall?
I didn't realize. Sorry, I was doing all that with OBS above so people couldn't really see what was happening.
Oh, I saw that question, but I could see everything fine. What was OBS covering?
So OBS is not capturing games very well right now in version 25. In fact, it's still super laggy. So even if I look at my OBS
it was just the
capture,
frame rate. Okay.
yeah, it's terrible, and I don't know why. So this is with OBS moved down below the bottom, so it's not working anymore. I tried to find a place to download an earlier OBS, and I couldn't figure it out except from shady Wares sites. Like there are source downloads available, but
Let me see if I have my installer. If you're willing to go back to my
yeah,
old
dude, if
version.
you want to give me like OBS 24 or 23 or 20, I'll take anything at this point, dude, because this is awful. Yeah, so that frame rate is terrible. I don't know why it's so terrible. Sorry, everybody. So you probably couldn't even see the acceleration I was talking about mostly.
I thought I was seeing it, but I might have not been seeing it. Like I thought I was seeing it, not understanding it, or something. I think.
Yeah.
I am on version 0.659b.
Really? The current version is 25.0.1, so they like
I assume they
completely changed their
convention.
scheme. Yeah.
Yeah.
I'll take that one maybe. How old is that?
The installer I have is actually even older. It's 2014.
Okay, I'm a little bit scared of that.
I mean, the one I have which is like, it's still a 0.6. It's just a slightly different number. I don't know why I don't have the new one. I'll hunt around slightly newer one. But I mean, I don't know. It works fine for me. Like,
Yeah, maybe we'll think about it.
you can always reinstall the new one if it doesn't work.
That's true. That is true. All right, let's end the stream now.
But it is
though.
ancient. It is absolutely ancient. Go ahead.
All right. Thank you, everybody, for coming by. We still have 600 viewers, which is great. All you people are interested in babbling about programming. Yeah, we've done 3 in a row about compilers, so next one will be about games, and that'll be cool. And then maybe we'll do more compilers. I don't know. Who knows? You can visit. I'm going to put Sean's URL in the chat again. It's twitch.tv/nothings2 if I don't typo it. And he is not streaming right now, I don't think, but sometimes he does. So if you drop him a follow, you could see when he works on the compiler that we discussed here, if he so chooses to stream it, which we're not promising, I guess. But
Yeah.
when's the next discussion? I don't know, maybe approximately a week. Depends on, so if Sean's free at that time to do this discussion, and also if the code's ready, which I thought it was going to be ready for this week and it wasn't. But yeah, thanks everybody for coming by. Thanks Sean for doing this and giving Casey a break. And yeah, next time. Let me do a raid.
Oh, have you not turned it off yet?
No, I haven't.
I have the lag, so I can't tell.
Okay. Is it really that much lag? All right, we're raiding Devin today because we haven't raided him in a long time. As soon
It's
as
probably
the
not
raid
that
goes
much
through,
lag.
I'll shut it off.
It's probably not that much lag. I just can't tell. So.
Boom. All right. And